how do you define focus in the brain? Like, what is it?
Think of attention and focus like a muscle. And the more you use it, the more those circuits become thicker and crystallized.
You being a brain specialist, right? I'd like to speak about imagination and the importance of imagining. And what does that do to your brain? How does that help you as a person?
Whenever you see yourself in a situation and you have visual imagery, you engage some of these spatial centers in your brain.
So plasticity means the ability for change to happen.
Absolutely.
In your brain.
Yes.
And where does that ability come from? Is it something that comes with age?
You can train it, and the brain can change its structure so it becomes more disciplined.
A psychopath is usually a very smart person.
Yeah, typically very smart, but not often. But if they're not that smart, they become, and I say if you have a psychopath and he's not that smart, he becomes a criminal and he ends up in jail. If you have a psychopath who's extremely smart, he becomes like a big business person.
Ready? Welcome to Kuwait.
Thank you, brother Faisal.
Baland, Dr. Baland.
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 Yeah.
What does it mean?
Baland, it memeans tall, in Kurdish.
Really?
Yes.
Do we have an equivalent in Arabic in terms of a name that means tall? رفيع. ممكن.
رفيع, I think.
رفيع.
أتذكر رفيع.
رافع رفيع. Yeah. تتحدث في اللغة العربية.
كلام شوي عربي نعم.
عجيب. Welcome to Kuwait. The cool thing about our conversation today is just the context of the conversation that I'd like to talk about before anything else. يعني ما شاء الله, what you've accomplished and where you are now and what you're working on, being an expert in the brain and the added value that you're bringing to that industry and that realm, and being a Muslim at the same time is very inspiring for me personally, and I'm sure very inspiring for this part of the world.
Thank you, brother.
So bringing this and with you today gives us a lot of inspiration, and to be able to understand that we have a lot of stereotypes just being part of this world.
Right.
So just seeing someone that holds that identity, and mashallah, even before you came here, you asked me if you want to pray before starting, and that came from you. Yeah. Just having that identity and holding it with you and being very proud of it and showing it. And I've seen a few episodes that you've done before, and you show it in a very nice, gracious way, and that's something that inspires me before anything else. That balance. So I'm excited to get.
Thank you for those nice words, by the way. I mean, identity is everything. I think for me, from the very beginning, being authentic to who I was as a person, and not being afraid of showing that, no matter where I was, has been a core to my life and my success, if you want to call it that. I don't want to call it success, but whatever life has brought me, it's the blessings of God, and staying true to who I was always at the center,
Really?
Yeah.
Finding strength through that. But one strength that you found early on, you were less than an average student. You were more of a D student, if I say, like less than average, and then but with discipline and consistency. And I'm going to quote something that you've said before, that the brain can change. It can change its form. Once its form changes, the personality and discipline changes. And do you think that your brain changed, and going from a below average student to one of the top students of Ramachandran, who is a renowned
that's true.
Scientist.
Yeah.
So how are you able to make that transformation? What happens to the brain when you put discipline in it? I just want to know more about this.
What happens? Yeah, well, it's a long story, so we have to go back first, and I'll give you some context in terms of narrative.
Okay.
So it all started back in Copenhagen, Denmark. Or actually, before this, I was born in Bulgaria. My parents fled the war from Iraq, so originally Iraqi, came to Bulgaria, came to Denmark. I was in a refugee camp, very poor. We moved to the ghetto. And in the ghetto, as we know, everything is sort of hard. I saw a lot of things in the ghetto. My friends were shot at, stabbed, crime everywhere. Things, a very hard life. And I think for me, poverty, all that, I was exposed to all that. Then came school. I was really bad at school. I got poor grades. Science was the worst for me. I hated chemistry, physics, biology, science courses. I hated. I mean, it was the worst. And then once I got to high school, still doing poorly generally. I never thought that I would go to university or go to Harvard. Do research at Harvard, lecture there. Never thought this would be an option for me, or work on the Ramachandran, one of the greatest neuroscientists. These are huge blessings. So how does it all come about? And I think, so we know that the brain is, we have, all of us, our brain are fixed. We have a certain fixed brain that we are born with. And this is genetically, in carved, that, the genetics predispose you to how you react to life and various circumstances, right? So think about it this way. You have genetics, so these are your genes. You inherit that from mom and dad. And then you have epigenetics. Epigenetics has to do with your genes turning on and off. So for example, let's say you have, I'll give you an example from the animal world.
Okay.
So you have mice, for example. Mice that are groomed by their mothers, licked, caressed, licked, and so forth, and so forth. These mice will be much more, they will be much more resilient in the face of stress later on. Okay.
They've been looked after.
They have been cared for. They have been looked after. They have been groomed by the mother. Versus a rat that has been neglected. So a rat that has been neglected, or a mouse that has been neglected, will literally be very vulnerable to all kinds of stressful situations later on. So they will, that what you might call a protective, shield you might have goes away. That's one example. I'll give you more examples. So you have mice. So you have mice, and these mice are, let's say you expose them to a certain smell and you give them an electric shock at the same time. So they smell it, so they smell it, and then you zap them. Smell, and you zap them, right?
Yeah.
Now these mice, their children, the children of these mice, later on, when they are exposed to the same smell, so they smell that smell, they will feel fear. They will have fear reactions simply from the smell.
Okay.
Without being exposed to the electricity. Does that make sense?
Yeah. So that feeling carries on into the generation.
It carries on through the genetics, right? And this is really the kicker. So even the children, like the offspring of these mice, when they are exposed to that smell, even they will feel fear merely from the smell, without having been exposed to any kind of electrical shock.
So what you're saying is we have a lot of things that are built in us that we carry from our...
Absolutely. So what I'm saying is that within our DNA, we have methyl groups that sits on the top of the DNA and turns genes on and off. So, and these could be genes for anxiety, stress, depression, and things of that sort. And mind you, my parents had a lot of that kind of thing in their lives. My mom, she in Iraq, as you know, with Saddam Hussein and the war and all that, a lot of things she saw. For example, at one time, do you know Halabja, that city?
Yeah, Halabja, yeah.
Yeah, she went to Halabja with her mom, and they were sort of walking, and as they were walking to the city, and they were going there, obviously they were taking cars and taxis, but at some point they would also walk between certain places. Bombing would start happening in Halabja, and they would hide, for example, in sewers and things like that. Very traumatizing. And then once they got to the city of Halabja, they would see corpses everywhere. And her mom would sort of engage in sort of helping, like, clean the corpses and things like that. So that was her life, seeing these kinds of things, being exposed to these kinds of things. So for you and I, Faisal, we get like COVID-19 and these epidemics, and we get all like frustrated, and we go, oh my God, our life is so hard, it's so bad. But these people, our parents' generation, completely different.
Yeah.
My dad, same thing. So both my mom and dad were orphans. My dad, for example, he was supposed to go to, he was called by the Saddam's army, Saddam Hussein's army.
He's Kurdish.
He's Kurdish. So they called him to come and fight against Iran. So he decided not to. So he didn't want to go to, he was very close to joining because, he didn't really have a choice. But he decided to escape to Bulgaria, the place where I was born. And thank God he didn't join, because that group of people that he was supposed to go with, they were all bombed on this big bridge, pulverized. So this was the kind of life that they lived. My mom, even in Copenhagen later on, whenever she was like any kind of fireworks, anything like that, she would be thinking that was bombs and hide and, beneath the couch. And
so that sound that she heard when she was young,
exactly.
when it comes back in a different way.
Exactly.
That's where PTSD comes in, right?
That's where trauma comes in. And I think I inherited all those genetic, epigenetic markers. So in the DNA, in the genetics, the epigenetics, I had that too. And so you can imagine my life too, So as a kid, I probably was more, stressed versus other kids. I remember, like, I had Danish friends. I would be afraid of their parents sometimes. And, and mind you, the ghetto was hard too. A lot of violence. Sometimes you just go out and walk about and somebody might jump you and hurt you and beat you up. And then you had to learn to fight. And so it's a long-winded way of saying we have genes, but through our parents, we inherit certain, markers on these genes, and they can influence us in crazy ways.
So you were able to change those markers, or what did you do? Because you were a product of your environment, correct?
Mm-hmm.
And the product of the environment that you were living in,
yes,
was no surprise. You were a below average student. You didn't go to school much.
Correct.
But now you work with Harvard, Cambridge for 4 years, and you are very well established.
Thank you, brother.
What did you have to do at a young age? And I'll get to young versus old later.
Yes.
But what it is that you've done that you were able to
change my brain,
just change your brain and just change the person that you are?
Absolutely, it's a great question. I think for me, first of all, I think all of it was the blessings of God. I mean, I know we're starting heavy out with the religious stuff. I don't usually go that much into that stuff, but I'm completely open to doing it because it's what I, truly believe in. But on you go on American podcast, they don't ask you much about faith and all that. It's a bit different. So for me, I think definitely the identity that I had in God and the belief and my faith in God really got me through a lot of those traumas and a lot of the things that I saw, in my life, being put in prison. And I was sometimes, I would go to another place, like a travel with my uncle to Sweden or something, and we'd get to prison, for one day, or, they thought we might be criminals, all these because of our color. Literally, there was a lot, especially like 20 years ago, there was a lot of racism too, a lot of racism.
Yeah.
But getting to your question. So I think having a clear-cut identity and belief in God and faith and never hiding that. You see, a lot of us, hide our identities, thinking that if we are somebody else and not staying authentic, that's going to get us ahead in life. But that's not the case. So I always held on to that. And I think that kept me on the path. Something else that I think inspired me. So the question is, so how did I literally get from poor grade, literally what happened? And that can explain my brain, I think. I had like this jump. Something happened when I was around 17, 18, in the ghetto. As things were very hard, I had these few months where I really thought about life, the meaning of life. And this is where I got more spiritual as well, thinking about, what's the purpose of all this? So I started to read books, become extremely interested in science and in knowledge. Existential questions, why do we live? Very deep stuff.
I think everyone goes through that.
They have that, right?
But maybe you did go through it a little bit earlier than everyone. Most people I know, they go through that in their mid-20s, late 20s.
I think it's just because of the hardship and the pressure. So I think the pressure of running around in the streets, seeing a lot of tough things, and then going like, okay, I'm Kurdish from Iraq. My brother here is Turkish. This guy's Arab. We're fighting with this group over here. They're, Yugoslavians. What's going on? What is all this about? Why do I, what's the purpose of all this? And this gets you to really to question it. Is there something beyond all this madness, right? So I thought about all this, and I thought, okay, what if I travel to some different country, try something completely new? And that's when, in my mind, I thought, what about going to Egypt? I always was fascinated by Egypt. I went to Egypt as a young kid. I was like 15, 14 on vacation. We'd been there, and I really liked it. And I was inspired by the story of Joseph in the Quran as well. It's a beautiful story. Okay, what about going to Egypt? Now, obviously, we didn't have the money to go there. My dad had a little pizza shop, so he could probably finance me a little bit. But I thought, okay, let me try that. And as I went to Egypt, initially, I was lucky. I got into the American University in Cairo. And I think my grades were extremely poor. So I think they they were lured by they got sort of the fact that I was Danish and European. They like to have their portfolio from different countries. You see?
Diversity.
Yeah, diversity, and I think that really made it, easy. So I went the first semester. My dad was able to support me the first semester. But then I did so well the first semester. I got straight A's that I was the university financed the entire 4 years. So now the question, Faisal, is saying, how can you go from being so stupid, not having
that's behavior, right? Like you're used to being lazy, not reading the whole content of what you need to study,
right,
to being a straight A student. And there wasn't ChatGPT at the time.
There wasn't ChatGPT. I think what it was is that, okay, so when you learn new things, when you engage in learning, reading books, for example, and you are intensely focused on this, you have a lot of neuroplasticity. So I had a lot of plasticity in this point. And then let's go into the science here. What causes your brain to change? First of all, when you are young, when you are especially in those 18, 19, 20, 25, your brain is it's more plastic than an older person. We know this.
So that's
generally
fact, huh?
This is known. Yeah, as we get older, we have less plasticity. This is one.
And what does that mean to have plasticity and not to have plasticity?
Plasticity means your brain can change its shapes, right? So you have your current brain. It has frontal lobes. Okay, we have a brain here.
Yeah.
It has the frontal lobes right here.
Yeah.
It has this is involved in higher order thinking. It has the occipital lobes here. This is involved in vision. You have motor strip involved in movement. Breathing part is down here. Okay. You have a place here for speech, understanding language, and so forth. So this is your brain. Now, we have a fixed brain. As I said, it's predisposed genetics. We have a certain brain. Now, it can change its shapes. The younger you are, the more it changes. In fact, a baby's brain is hyper plastic, meaning it can change its shape a lot. And by shape, I mean, if you are, let's say, and not a very disciplined person, you can train it, and the brain can change its structure so it becomes more disciplined.
So for us to compare kids, and that's maybe we're speaking to parents here.
Yeah.
For us to compare kids, sometimes parents will be like, am I going too tough on him by trying to wake him up super early or trying to get him disciplined?
Yes.
Because if I were to do the same thing and try to change the way I'm behaving, it'll be very tough on me.
Right.
But relatively, it's not as tough as it is on kids. So is that true?
Yeah, so that could be an example. But the question is, what changes habits, right? And what changes the brain structure itself?
Yeah.
So, absolutely. So habits is a example of plasticity, changing habits, But plasticity is deeper than that. It could even be somebody who is paralyzed, so they have a stroke and their arm doesn't work, and then you get it to work a little bit again. That's an example of plasticity as well. So plasticity can be speech, behavior, anything that has to do with brain function that can change, right? So this is all plasticity. An example of plasticity is if you have a kitten, a little cat, right? And you, in the first few weeks of its life, you sew its eye, so it's blindfolded. It cannot see from this eye, right? Okay. And then after, let's say 8 weeks, you open up the thread here, and you can see, and it opens his eyes. It turns out that kitten is now blind for life. Okay, it's blind for life just by sewing the eye, for a few weeks. And the reason is that in the brain, in the back of the brain, you have the motor cortex, right? And the right side of the motor cortex controls the left eye, and vice versa, right? So on each side, so everything on the left, okay, is controlled on the right, and each in that way. So my left arm, right side of the brain, and so forth. Now, in that kitten, the left eye was closed, right? Now the right occipital lobe, right side of the brain involved in vision, actually shrinks. It shrinks, and the left side takes over the right side. It invades it. Okay. Because the brain is a use it or lose it brain, meaning if you don't use a certain part of the brain, nearby structure will take it over. The brain is very
efficient.
It's very efficient. Exactly. It's very efficient. And so if you don't use certain parts of it, it will be taken over. Now, in this case, the left eye didn't work, but the right eye became a super eye. The kitten's right laser eye, because it got all the cortical real estate. It got all the brain power from the other part of the brain. You see what I'm saying?
Yeah.
It took over that part of the brain. So this happens for anything. So let's say you play a lot of tennis.
Okay.
You start using your hand a lot. You play. What happens then is that the left side of the brain, you have a motor strip called it's called the motor cortex. It's right here on the left side for the, okay? That part will now, as you start using your hand, it will expand. The neurons there will become, they will grow more synapses and that area become larger. So everything that has to do with your arm, that arm area, literally we have an arm area in the brain that will expand. Does that make sense?
Yeah. So
the entire, sorry if I interrupted. The entire body, in fact, entire body, the physical body, is all mapped on as a little man in the brain, meaning there's a representation of your entire body in your brain. And those neurons these are neurons, that are, their only job is to make that function work. Okay, they represent your arm. Okay.
So plasticity means the ability for change to happen.
Absolutely.
In your brain.
Yes.
And where does that ability come from? Is it something that comes with age? Because there is, obviously age has to do something with it. So what happens when you grow older? Why does the ability shrink? Is there a specific hormone that gets missing, or what happens exactly?
That's a good question. So there's several factors. One of them is, in order to have a lot of plasticity, you need growth factors in the brain. So you have neurons. These are cells. There's about 100 billion of these in the neurons. About 80 billion on the outside surface called the cortex. So the brain, it has an outside layer, it's like a helmet. It's called the cortex. Okay, plus 80 billion neurons there. And in order to have plasticity and growth, you need growth factors. These are small proteins like fertilizers on the brain. And they have fancy names like BDNF and GDNF. And whenever you have a lot of these fertilizers, these growth hormones, you will grow new synapses between neurons. So you have the neuron, right? The neuron here, it has an axon, like a projection. And then on a nearby neuron, you have a dendrite, which is like something that receives information from that other neuron. And then in between that, you have a synapse, a little gap where all the magic happens. And then whenever you have neuroplasticity and a lot of growth factors in the system, you will grow new synapses. And mind you,
so with less fertilizer,
yes,
less protein, you will have less
plasticity,
less synapses, which hence means less plasticity.
Exactly. And then Faisal might ask, and how do you get those growth factors?
Exactly.
Get those bloody growth factors, right?
I'm gonna go buy them from the supermarket.
Exactly, right? Well, there are a lot of things you can do. So exercising, for example, doing tons of exercises. I remember, this is interesting, when I was in Denmark, I rarely did any exercise at all.
Okay.
I was always like, the only exercise was maybe running from the cops, or something. And when I'm saying running from the cops, I wasn't even doing anything criminal. Yeah. This is funny, whenever I saw a cop, I would run when I was a kid. I was scared of police, because they would always just take us and put us in jail or like search us. And sometimes, they would just take you down your bike and just like put you on the floor and just, shout at you. I had that happen a ton of times, even though I was like
So you developed that kind of relationship with
if you just see police, I would just run. So that's pretty much the only exercise I got. But in Egypt, I started to play soccer. I started to be more active. So that's one factor. Vitamin D, a lot of sun, that can help certainly. BDNF, you get that from a lot of reduction in stress. So cortisol can lead to tons of inhibition of BDNF. So if you have high cortisol all the time, you're stressed all the time, that is a reason for inhibition of this.
So when you say exercise, what kind of exercise are we looking at?
We're looking at cardiovascular exercise.
Cardiovascular.
Yeah, mainly cardiovascular, meaning things.
So runners. Because a lot of the listeners are between 24 and 38.
Right.
In بدون. And they're at an age where they need some factors to help them.
Yes.
Want to drive change.
Yes.
Habitual change in specific.
Right.
In their life. And personally, I'd like to create that environment for myself where it's easier for me to, because we're humans, we're constantly trying to develop, right?
Right.
So exercise being a cardiovascular exercise in terms of running, that helps more than strength. Strength is important, but we're speaking specifically about the brain.
Plasticity, yes.
Yeah.
It's cardiovascular exercise. It is reduction of stress. It's sleep, good sleep. During REM sleep, for example, we can go into sleep later, but during REM sleep, you have tons of plasticity as well in the brain. And also just having good sleep is a factor for reducing excess cortisol.
Yeah.
I would say social relation is another one because it's a buffer against stress. So you can do that to get BDNF. Another one is traveling. So, for example, anything that has to. So think of BDNF in the following manner. Whenever I do something novel and rewarding, I have more BDNF and GDNF in the system. Meaning, so I flew in here. I was in Copenhagen. I came to Kuwait.
Yeah.
Right. Kuwait is new for me. I've never been here, even though I'm Iraqi, Kurdish. I've never been to Kuwait. So when I came here, everything was novel. I looked at your beautiful towers. I looked at everything, the beach, everything wonderful, right? At this point, whenever I look at something new, you have attentional systems of the brain turning on. Attentional systems it's a part of the brain called the nucleus basalis. It's pretty deep in the brain. It has neurons that produces acetylcholine. Okay, acetylcholine is involved in attention, focusing on new things. Now, as you go about in your daily life, you come here to the studio, everything is sort of repetitive, nothing novel. You just kind of go and, this same elevator, same people. Hello, how are you guys? And you sit down. Nothing novel, nothing, really interesting.
So your brain says we don't need any more BDNF.
So the brain says no attentional system, nucleus basalis, stay turned off, no acetylcholine, no attention. And once the nucleus basalis is turned off, there's no BDNF and GDNF. So this is one factor, right? Second factor is when you have novelty as well, you have dopamine and reward. And this is another part of the brain called the mesolimbic circuit. It's a circuit in the brain. It goes up to the frontal lobes. So deep in the brain, up to the frontal lobe. This prefrontal lobe here has to do with high order thinking, planning, discipline. Okay. So literally, if you have damage there, you lose discipline, you become erratic, you may become, your personality changes. So you curse all the time and all that. So discipline is pretty much in the prefrontal lobes. So now.
So this is where discipline is.
Discipline is in the very front. We can go into that as well in a second. But my point is, the mesolimbic and the dopamine and the reward pathway is also a part of the whole BDNF and plasticity circuit. So meaning, if I want plasticity, I go to a new country, I see new roads, I see new buildings.
So indulging in new experiences.
New experiences. That turns on the two systems we need for plasticity. One, the attention system, the acetylcholine nucleus basalis system, okay? Attention system, in other words. And the second system, which is the reward system, the dopamine system.
Okay.
Now, give you an example. So when I was reading books in the ghetto for the first time, everything was novel.
Yeah.
Everything was new. I was learning about Shakespeare for the first time. I was learning about Nietzsche for the first time. I was learning about, Prophet Joseph for the first time. I was learning about nucleus basalis and the brain for the first time. So all this was novel and it was highly rewarding. So what do you get? Plasticity. When I moved to Egypt, sun, reduction of cortisol, exercise, what did I get?
Plasticity.
I saw new things, new buildings, new roads, new, pyramids. What did I get? Plasticity. So I think this all changed my brain and changed its shape from its previous.
You expose yourself to a new environment.
Exactly. And the reason, by the way, this happens is that your brain is has the following logic. It says, if I'm in an old environment, let's say in the savannah or something like that, okay, 1,000 years ago, 5,000 years ago, there's nothing new if I'm just running about in the same old jungle, right? Same, nothing happened. But whenever I go to a new place, a new territory, what happens? I need to be aware. Maybe because now the lions could come from a different place I'm not aware of. Everything is new. Threats are everywhere. So it makes sense for the brain to change its shape to fit the new environment, right? So it has attention and it has reward as well, because reward could also be looking for new,
So it's an adapting mechanism.
It's an adapting mechanism, yes. It's an adapting mechanism.
Interesting. So you spoke about attention. You spoke about focus. You also brought that up. And that really is something that helps me a lot. Well, I was watching an interview for Magnus Carlsen. He's a chess player.
Yes.
And they asked him, obviously, whoever doesn't know Magnus Carlsen, he is the champion of modern chess. And no one comes close to him.
Yes.
And he's on top of the game for a very long time. He became world champion when he was 18 or 19, and he stayed until he was 30.
Yeah.
That's unheard of in chess for someone to stay on top for a very long time.
Right.
They asked him in an interview, he asked him, what makes you a champion? His answer was simply my ability to focus for long periods of time.
Yeah.
And when I started looking into focus and finding flow, and maybe we can speak about flow state and
Sure.
those little things.
Yeah.
And that's where what I would like to speak about is that type of focus that puts you in a situation where you lose track of time.
Yes.
And lose track of what's happening around you. You're so indulged in the moment, and that is something with social media, with what's happening with using like these screens, we've lost.
Yes.
Or it's difficult to get into that zone. There's so many things happening, so many disruptions. Yeah. So what I would like to speak about focus. How do you define focus in the brain? Like, what is it?
It's a deep question. So how do you define focus? Focus is focused. You have focused you have circuits in the brain, in frontal parietal lobes, and the prefrontal lobes up here, but also going back to this part of the brain. This part of the brain, the parietal lobes up here, has to do with spatial navigation and understanding the space around you, and also you understanding your own body position and things like that. So this is the attention circuit and the focus circuit. Now, how do you train that? Well, you can train it actually. So it's like a muscle. Think of attention and focus like a muscle. And the more you use it, the more those circuits become thicker and crystallized. More, literally that, the synapses, you grow more synapses and the fiber become thicker by simply, by paying attention more. Okay. So this could be focusing on whenever you...
So it's a muscle.
Think of it as a muscle. Yeah. Read, and whenever you read several pages without getting, having attention distracted, those circuits become reinforced and stronger. So that's an example of that, how that happens. And the flow state as well, you mentioned flow. Flow is another interesting way to really lose yourself. So for me, I hate to promote things, but I have a book coming out in a month. Okay. And
what is it?
By the way, it's in Danish, so you can't buy it, so it doesn't matter. It's more bragging than anything. It's not really promotion, okay? I got the opportunity to write.
So Danish is your first language?
Danish is my first language. I got the opportunity a few years ago to write a Danish book, and it was a bit odd for me to write a Danish book, but they sort of flattered me to say you can write your life story. So my vanity said, okay, let me just do it.
Yeah, okay.
So, but I have a lot of things there on flow and the flow state, and I think flow for me also is something that really helped me a lot.
Let's define flow for the.
Flow is is you lose yourself in a. It was first described by Csikszentmihalyi. Mihaly Csikszentmihalyi is a Hungarian psychologist, co-founder of positive psychology, and it's when you lose yourself in a certain thing that you're doing. It could be playing tennis, it could be playing soccer, it could be painting, and you lose sense of time, space, and you kind of, in the prefrontal lobes deactivates a little bit, and because you're just kind of you reach this place of no time, no space. It's kind of all, you're completely immersed in that activity.
So think of it that way. Sometimes you sit with people and an hour or 2 hours go by and you just don't feel it. And there are people with 10 minutes, it feels like an hour.
It feels like an hour.
So that's a flow. Yeah.
Sometimes flow can be a challenging thing, can increase flow. So for example, I did a study with Csikszentmihalyi. Actually, we published this paper together, and another brother another friend of mine called Abu Hamdi, Sami Abu Hamdi. We have published a paper together, showing that when you play like a video game, and your contender, like the one you're playing against, you lose by like a small margin, like 4-3 instead of instead of winning 10-0, you win 4 to you and 3 to your opponent. That increases flow more. That's more sort of engaging and so that challenge. So
without the challenge, you won't be able to get into a flow mode.
You get more flow.
With more challenge.
You get more sort of the flow mechanisms, in other words. In other words, did you see the World Cup final in Qatar?
Yeah.
How interesting was that?
Amazing.
A lot of challenge, right? Although you weren't playing yourself, but you kind of put yourself in the shoes of Messi and all these guys. Did you like Argentina?
Yeah, I was supporting football. I don't support any of both of the. I support Italy personally. I like Italy, but at that point I wanted Messi to win. Yeah, I was supporting Messi.
I was supporting Argentina and Messi as well. And for me, like I was literally like almost felt like I was on the pitch playing, right? And it was so interesting and so immersive, right? And
yeah, that happens with anyone who supports a specific team.
Yes,
right,
100%. Yeah, and so that increases a lot of flow. And so I think in life having challenges, it's a great thing. So for me, reading books for the first time, and that was very challenging. So that increased flow, and then in turn attention, and then reward as well.
I was in a very similar situation. I never used to read books. And then I picked up a book of Malcolm Gladwell, Tipping Point. That was when I was very young. I was in my early 20s.
Yeah.
That was the first time when I started picking up books and reading.
Right.
And that, you saying that reminds me of myself. I went through the exact same experience where it was difficult for me, but it was challenging, and I was finding a lot of value just from reading.
Yeah.
And that kind of made me want to try new things.
Yeah.
So so focus really is a muscle. So if someone wanted to increase focus, because do you think, you being a brain specialist, right, with the effects of social media, and I don't want to be negative, really. I just want to be very, very realistic of just using not just social media, just be using your phone.
Yeah.
Does that hurt attention and hurts focus, or what does it really do?
It does. It does fracture your attention. It's small bits of high peaks of dopamine. So it goes like, you see something exciting, dopamine peak, right? So a spike, dopamine. And this will literally like fragment your attention. It's horrible for attention. And each time, by the way, you have dopamine going up, it crashes. So it's almost like an addict looking for another hit when you go for another video.
Is it the same effect on the brain as drugs?
To some extent, yeah. Like it can become a behavioral addiction. People that swipe all the time and just looking for videos, and it fractures attention as well. So social media, when it comes to social media, I definitely recommend like long form. Not because this is long form. You probably also have bits and pieces on the internet in short form, but it's much better for attention and focus. It's much more like reading a book. So that would be an example of something that can really some of the small like TikTok stuff can really can be highly addictive and also just fracture your attention. So that would be an example.
Okay, so let's get into more topics about the brain.
Sure.
Because it excites me, because everything ties back to the brain in terms of behavior, what you do, and maybe we can speak about normal behavior of people. And you mentioned, sometimes people say this guy has a big brain. Is it actually true that some people with bigger brains are smarter, or is that not?
It's interesting. So it turned out, no, it's not true in the literal sense. So Einstein, for example, was very smart, by the way. He was very smart. He has, I believe, a smaller brain than average, but parts of the brain, like his angular gyrus, so we have a part of the brain here, it's involved in mathematical thinking and, serial thinking. That part of his brain was huge. So certain parts of your brain have to be big, So having a big motor cortex, for example, that could be very, advantageous if you're a tennis player or something. If you play, hockey or, something like that. But generally having a big brain doesn't mean that's the key to a great brain.
But what about IQ? What is IQ?
But don't get it wrong, though, by the way. Having a big brain is also part of being human. I mean, big brain is a good thing. That's why it's so... The outer layer of the brain, in fact, in humans is folded like this. It looks like a cauliflower on the inside. It's because, it's kind of to squeeze it in and make it more... have more of the outer layer of the cortex. So that is a good thing. But again, an elephant has a huge brain. It's not much smart. It's not that smart.
Yeah. Some myths that people say. So... what about IQ? Intelligence.
Yeah.
And I'd like to speak about IQ versus EQ, and how does that work, and how is that represented? And is this something that we can build? Is it something that you're born with? Just a little bit about that.
Yeah. So there's different forms of intelligence, as you know. You have more sort of the computational intelligence that is very very prized in the Western world, which is the IQ kind of intelligence. That's where you are able to solve abstract problems quickly. That has a representation in the brain. As I mentioned, the angular gyrus would be involved in that. Things like artistic intelligence would be more the parietal lobes, a region called the inferior parietal lobule. Now, I'm throwing these fancy names at you, but there's a reason for it. So the IPL, for example, the inferior parietal lobule. Think about it. There's a part of the brain right here. It's involved in things like spatial, like navigation, but also things like artistic talent.
So is that true? The left side of the brain is represents
art more, and then math and left. There's actually some truth to that.
Actually,
there's some truth to that. Yes.
Okay.
It's not as black and white as we see, but there's truth to that. So, in the right side, the IPL, for example, if you have a stroke to the left side of the brain, what happens is that think of the two hemispheres always competing. So each side of the brain are competing and they are inhibiting each other. So the more mathy left side of the brain is inhibiting the more artistic right side of the brain. So these are wrestling.
Oh, wow.
This is actually is a principle in the brain in its entirety. So, for example, the fear part of the brain is being inhibited by the pleasure part of the brain. So the amygdala, it's the fear part. Not only fear, but there's mainly fear there. And the septum, which is the pleasure part, inhibits the amygdala. Okay. And this is an overall principle in the brain. The prefrontal lobes, the discipline part, inhibits the impulsive part. So this is how the brain works.
Also, they work against each other.
Antagonistically, yes, they inhibit each other. So if I was to damage your prefrontal lobe, there's actually, as I mentioned, I didn't mention that, but there's a case of a guy who has his prefrontal lobe here. He had a spear go through it, an iron rod. And so his impulsive part of the brain took over and he became impulsive and he couldn't hold a job. He couldn't hold relationships. He became erratic. His personality changed completely. And this is because now his impulsive, emotional part of the brain took over.
There's this emotional intelligence book by Daniel Goleman that I read a very long time ago, and he mentions that story about a girl.
Yes.
Is it the amygdala, which is in charge of fear, right?
Yes, it's partly mediating fear. It's behind the ears.
Yes, behind the ears. Okay.
Yeah.
So that part got damaged, and then she was, I can't say the word because I'm on YouTube, but a guy did something to her. Mm-hmm. And then she asked the guy who did that to her to take her back home because she just doesn't have a sense of fear.
Yeah.
So that was a story when I realized that maybe a small part of your brain that can be damaged, that can affect your personality, right?
100%. So there's another case of a guy who lived in the U.S. What he did, he was in Texas. One day he woke up and took a rifle, went to the Texas Tower, went all the way up in Texas Tower, the big rifle. With the butt of his rifle, he killed the receptionist of the tower, went up to the tower and killed 13 people. Completely normal guy, completely non-criminal, non-violent, nothing. Okay. And even a guy who was a pedestrian trying to save a pregnant lady, he got shot as well. Now, at the end, the cops was able to kill this chap, and lo and behold, they looked at his life. His name was Charles Whitman, I believe. Look at his record, and it turned out he had written a letter, and he's gone to the doctor many of times, complaining about headaches, saying, lately I feel like I'm violent. I have these violent impulses. I don't know why. Doctor, he went to a doctor pleading, check my brain. There's something going on. When I die, check my brain. Then he did all this. They looked inside his brain. There was a tumor growing on a part of the brain called the hypothalamus involved in aggression. It's nearby the amygdala, and it was actually pressing on the amygdala itself, and this caused them to have this erratic behavior. Mainly only think about this, Faisal, from having a tumor. Think about you and I could have the same thing could happen to you and I. It gets into questions about free will. Do we have free will at all? What's going on?
Yeah, that's the question.
Think about it. This guy was completely normal, loved his wife, his mother. Now he goes out and kills 13 people just because of a tumor. And there are tons of examples of this. Another guy who became pedophile overnight. Checked his brain. He had a tumor growing on the hypothalamus. That's the sexual and aggression part of the brain. Removed the tumor, he became normal. The tumor grew back, he became a pedophile again.
Oh, wow.
So this is
so that comes into the question, free will, and I'm sure you've looked into this.
Yes.
And we had a small conversation about it casually yesterday, but we never dove into details. So do we have free will?
Sorry, by the way, I hit the table. I get excited when I talk about science, you see.
No, just you have to apologize to Munira, not me. Because she's the one who worries about the post-production.
I get very excited when I talk about science. Okay? So it gets into questions about free will. Do we have free will or not? You know, and personally, there's me, the Baland, the scientist, that says, okay, I have to look at the science. Yeah. Now, Baland, as a person, I would want to say we have free will because that's my beliefs, that's my personal beliefs, my religious beliefs. It just makes more sense as well. But the science, what does the science tell us about free will? Now, it turns out, but maybe 80 or 90% of scientists, neuroscientists will say we have no free will. Maybe 80, maybe 70. It's a majority, definitely.
Yeah.
No free will. And there are some experiments that would support this. There's something called the Libet experiment. It's an old experiment, I believe about 30, 40 years ago now.
In the 80s.
Was it 80s?
Yeah, 80s, yeah.
Good. 80s.
Yeah.
You've done your homework.
A little bit.
An interesting experiment. So they had these people sit on a chair, and they would have this clock ticking. Tick, 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 tick. Let's say 5 minutes. And then they would say, obviously I'm simplifying the experiment for you. They would say, within these 5 minutes, whenever you feel like it, move your hand. Okay? Reach out for, and move your hand. So they would do that, 30 seconds, they would move his hands. 20 seconds, he would move his hand, The interesting part, though, was half a second before he had the urge to move his hand, before he had his awareness of wanting to move his hand, a net-like antenna on his brain called an EEG was picking up on the signal. Okay? Half a second before he knew. So the scientist knew before he even knew himself. His brain knew before he knew himself. So this made scientists question whether we have free will at all. If the brain is, merely pushing you to have that urge and do that action. Does that make sense?
It does, yeah. But the thing that doesn't make sense is, then where is this coming from? If it's not coming from him, then where it's coming from the brain before he knew.
Yeah.
That was like hundreds of milliseconds, right? Before
Hard, yeah.
Before he actually,
yeah.
Before he acted, or was it, or before he was able to understand that this is something that I would like to do?
So before he had the subjective awareness of wanting to move, even.
Okay.
But it's so fast though, so it's hard to disentangle exactly because it's like half a second. So the signal, okay. Here the readiness potential. Machine picks it up, half a second to a second goes by, and then he moves, right?
But isn't that the signal of him telling his body to move?
No, it's the way it's interpreted is that this is, you have, before you initiate the intention of wanting to move, your brain already has a signal there.
Okay.
Does that make sense?
Yeah, it does make sense.
But then a lot of scientists will say, look, this doesn't necessarily mean we don't have free will. It just could be that there's a smearing of space-time when it comes to things like action and volition and movement. So it doesn't need to be 100% clear in terms of how the machines pick it up. So I think that is a logical argument. Libet himself would argue that we may have veto power in that whole dilemma, right? Veto power as in,
if your body has the urge to want to do something.
Your brain says readiness potential in the brain. I want, move, right? You have the intention then to move, but then you can, in that fraction of a second, that 500 milliseconds or a second, you can stop it anyway. So that could be one argument, but that's one argument. On the veto power thing, there's a thought experiment, if you don't mind, I might tell you about, because it kind of gets into this.
Yeah.
It's the following. My colleague Ramachandran told me about this, by the way, but it's originally by somebody called McKay, a philosopher. Let's say you have a super scientist from the future. He sits with you and he says, Baland, I'm going to show you Messi or Ronaldo, and you tell me which one you like more. Okay? But before you choose, this super scientist has a machine he puts in on my brain, and he can look at every circuit in my brain. It looks at my visual cortex as signals goes to the optic nerve, to my visual pathways, and then going all the way to things like acting and choice and volition and all that. And then he knows before I even make the choice what I'll choose, Messi or Ronaldo, Pepsi or Cola.
Oh, he will know.
Kuwait or Iraq, right? So these questions will come up,
That's a controversial question.
I don't know. I just made it up, right?
No, I'm only kidding, man.
But let's say you have to make these choices, right?
Yeah.
But the scientist, just based on neural activity, like the Libet experiment, he will know ahead of time what you will choose. Okay. So you'll say Messi or Ronaldo, and you choose Messi. And then the scientist, super scientist, will wave his little piece of paper and say, "Look, I already knew. I wrote Messi here." And then again, Barcelona, Real Madrid. He shows you the paper. Then Baland now goes and says to the super scientist, he says, "All right, I want you to show me that piece of paper before I make my choice." Right? There's a little gap of time. And then as he shows that to me, he shows me Pepsi. In that second, I can defy him and choose cola.
Yeah.
Anyway, and then he goes, "Oh, by the way, I had that built into the prediction," the super scientist will say, "and I knew that you will defy me." He might say that, right? He knew that Baland was very mischievous and he has a defiant personality and likes to go oppose people. So I had written that into the prediction. But then I might say, "Oh, anyway, I'm not going to go with what he thought I would do. I choose the other one anyway. I'll keep to my original choice." And it becomes an infinite loop. So
he will know.
Whether he will know or not, and whether I will, defy him or not. And it becomes an infinite loop. And so this tells us that whether free will exists or not based on these thought experiments is something that is very difficult to really pin down based on science.
Yeah, especially with consciousness. And maybe we can get into that a little bit later.
Sure.
We'll come back to that. But speaking of emotional intelligence and intelligence, IQ.
Yes.
And maybe that kind of brings us to love. Okay. And once we speak about love and feelings, I want to speak about different types of feelings, but maybe through emotional intelligence. So did we define emotional intelligence? We didn't get to that.
Emotional intelligence, we didn't. So we talked about I sometimes go off these tangents, you see.
Yeah, it's fine.
So I talked about the angular gyrus, the part of the brain that was huge in Einstein, and that's part of the math part of the brain. It's close to the spatial part of the brain. So that's kind of more the EQ. And also I'd say the prefrontal lobes.
The IQ, you mean, sorry.
IQ, sorry. Yeah. You're right.
Yeah.
Thank you for correcting that. And then the prefrontal lobes as well, it's also an IQ thing. You have working memory. It's part of the prefrontal lobes and the very tip above your.
So memory is a big part of it.
Working memory. So
memory.
You have different types of memory. So you have memory that's involved in, riding a bike. That's procedural memory. That's in the lower part of the brain. It's down here, riding a bike. But then you have things like episodic memories. That's remembering, how you guys treated me very nicely. I came here. Okay. So I put that in my brain. That's episodic memory. That's a seahorse structure behind the ears called the hippocampus.
And that's based on experiences.
But then you have working memory. That's the ability to manipulate numbers and remember your phone number. That's in the front part of the brain. That's a different circuit. But that part of the brain is also involved in what you might call IQ. Okay. Now, emotional intelligence is more sort of a different circuit in the brain. It has to do with things like empathy, understanding what is Faisal thinking right now, what is his agenda, and this is a circuit that it's mainly in the medial part of the frontal lobe as well. So this part has to do with. And this is actually very fascinating. You like this because. Think of it this way. If IQ is more in the angular gyrus and on the sides of the brain, there's a part here on each side, right? This is called the DLPFC. It's a mouthful, but it's an interesting structure. DLPFC, it's out here. This is cold cognition, cold intelligence, okay? Cold sense of dealing with the world. Utilitarian, that's out here. A psychopath has huge DLPFC activity, lots of activity in the DLPFC. He's smart. He has high IQ and he's intelligent.
So a psychopath is usually a very smart person.
Yes, typically very smart, but not often. But if they're not that smart, they become, and I say if you have a psychopath and he's not that smart, he becomes a criminal and ends up in jail. If you have a psychopath who's extremely smart, he becomes like a big business person.
Or a CIA.
Or...
they do that. They look for CIA. That's what I heard.
Yeah, psychopaths, right?
They look for psychopath traits. And
psychopathic trait, yeah. And then in the medial part of the brain, right here, this is where you have emotional intelligence. This is part of the brain that's involved in it's involved in the sense of like making decisions, but in an emotional way.
So how would you define making decisions in an emotional way, and how would you define someone with very strong emotional intelligence?
I'll tell you. So basically this, making decisions in an emotional way. I'll give you two examples. Like emotional decision making and a good, emotional intelligence. Okay. Example could be, I'll give you a movie example first. Have you seen Terminator 2?
A very long time ago.
I'll give you it. So in that movie, the Terminator, he says, this is the Arnold Schwarzenegger guy, wearing the leather jacket and all that. He says, now the move of the T-1000, the skinny kind of, the metal man, the liquid guy, his next move is to go and kill Sarah Connor at the hospital. Sarah Connor, she's in a mental hospital. They think she's crazy for talking about Judgment Day and all that. So now he says to the little guy, John Connor, he says, your mom will be killed next. Your mom will be killed next. She's in the hospital and all that, right?
Yeah.
And then John Connor says, John Connor says, then what happens to my mom? What happens to her? And then the Terminator says, she'll get terminated, right?
Yeah.
And then he says, that can't happen. We have to go save her. And then Terminator says, negative. We have to move. He will strike you and he will kill you there. He will find you. We have to go on. She's not important for the mission. She's irrelevant for our mission of saving you. And then John Connor says, it doesn't matter. You don't understand. We have to go and save her. It's my mom. Doesn't matter if I die and John Connor, by the way, if he dies, whole humanity dies, by the way. He's the savior of humanity. But because he's using the medial part of his frontal lobes, he has a lot of emotional intelligence and empathy. And he says, no, I have to save my mom. I have to save mom here. That's an example of that. The Terminator is a psychopath in essence. Yeah. AIs are psychopaths. Very in logical. Essence. There is no emotional consultation. So this part of the brain has a circuit to the emotional part of the brain, which is deeper beneath it. And it just consults it. It says, look, what should I do in this decision? Should I leave this girl over here, hurting this girl, or should I hurt my mom, or should I be selfish in this scenario or not? This is the medial. I'll give you another example, okay? If you don't mind, I'll give you another.
No, it's fine.
Thank you.
Take your time. You're here in Kuwait for this.
I'm here in Kuwait for this, absolutely. Yeah. So you have this train is running on this tracks, and it's about to hit 5 people. Okay, you're standing nearby. Okay, it can hit 5 people, but there's a side track, and if you press a button next to it, so Faisal is standing over here, and you press this button next to the tracks, the train will not hit the 5 people, but hit 1 person instead. Okay, what will you do? Will you save? You can do nothing else. So press it, and you don't press it, 5 people die. You press it, 1 person will die.
Yeah, it's a philosophical question, isn't it?
What do you choose?
The thing is, I've read this. I read about this before, and I know if I press something, it means you are choosing in this moment to go and kill 1 person. But if you don't press anything, you're being indifferent, and 5 people are
5
killed.
people are dead. Yeah.
I think not doing anything rather than killing 1 person, in my conscience, is more realistic for me.
So personally, you wouldn't press.
No, because I read into it, and I know pressing is me acting to kill 1 person.
I understand.
You know what I mean? But before that, I would have just said.
Before that, yeah.
Before that, yeah.
Turns out this is one option people will sometimes choose, but the most people though will be willing to choose killing 1 person.
1 person.
They say, okay, look, I have nothing to do. I'll just kill that 1 person. Okay, but I can definitely empathize with what you're saying, that it's very difficult not to press it, because you feel more responsible for that other guy's life. Yeah. This other thing is more like destiny. You can't really do anything. But
it's like it's a situation.
Yes.
Yeah.
But most people will say, I'll save that 1 guy.
You'll save that 4 people and kill that 1 guy.
I'll save that 4 people and save
5,
that.
yeah,
and save that one. Yes. Yeah. Have that 1 person die and save the 4. Right. Now there's a different scenario. You're standing on a footbridge above the train. Now the train is coming from behind, and it's coming. Okay, it's coming, and there are 5 people, a group of people there, right, about to be hit by that train. On the bridge, there's a slightly, overweight guy. You stand behind him, and by pushing him down, you can stop the train from killing the 5 people, but this guy will die. What do you choose?
I wouldn't push him.
You wouldn't push him.
I wouldn't push him.
Most people would not push him now.
Yeah.
So before, they were willing to press the button and kill that one person, right? But in this scenario, they're not willing to push him. And the reason is simply this: emotional intelligence. It's emotions. Once you push that guy, it becomes a physical thing. It becomes it's like a nearby, you're actually touching the bloody person. So it becomes something that activates the medial prefrontal lobes and the emotional part of your brain, and you just can't do it. Versus the other scenario before, you used your DLPFC. You used your utilitarian psychopathic brain in your choice. So it didn't have the same emotional load. In other words, you could easily choose whatever you wanted. Most people just choose to save the 5 people, but it was a utilitarian thing. It was like standing here and pressing a button and sending a drone to Iraq.
I wouldn't feel like I've done anything wrong.
Exactly.
Because there's between me and the drone a button.
There's a big gap. But here the gap is smaller, so it uses the medial prefrontal lobes. So in fact, if you bring a psychopath to the laboratory and you ask him this question, say, what will you choose? You know what the psychopath will say?
Would push, right?
I'll just push the bloody guy over.
Wow.
But this is the difference, because the psychopath has a what? The medial prefrontal lobe, the activity is low. In fact, even his amygdala and emotional part of the brain is low. That's why a psychopath can go about in life, no emotions, cold, callous, nothing. He drives a car, the cops is after him, what happens? No emotion, completely cold. Have you seen Goodfellas?
Yeah, I've seen.
In Goodfellas, they sit there, John Pesci and all these guys having spaghetti, and there's a dead body in the trunk, and they're sitting there and entertaining their mother with stories and laughing. No emotion.
No emotion.
Emotionless. The amygdala and the emotional core of the brain, no activity in a psychopath. The medial prefrontal lobe that has to do with emotional intelligence, no activity, and so they can just walk about in life. Does that make sense?
Makes sense.
You and I, if you drive a car and a cop behind us, what happens? Adrenaline, heart beating,
100%.
sweating. In this guy, nothing.
That's going to drive us to say, well, let me stop and just see what he wants.
Yeah, so this is the difference.
So, when you describe and explain things,
yes,
and those for people who are listening to this episode rather than watching it, what Baland does is he uses a lot of his body to explain stuff. He uses his hands, and he can see him imagining stuff and trying to describe what he's imagining. And maybe that's what I would like to speak about is imagination and the importance of imagination. When he spoke about football a couple of times, Messi and Ronaldo,
yes,
I think there was an interview for Samuel Eto'o.
yes.
He's a goal scorer. He scores many goals, and he says that he imagines the goal before he scores it. He imagines how he's going to kick the ball and where the ball is going to go, and he uses a lot of this. So I'd like to speak about imagination and the importance of imagining, and what does that do to your brain? How does that help you as a person?
It's a great question. It actually ties back to the thought that I had earlier, and I think I didn't complete completely, is that we have a part of the brain is involved in attentional, you could call it the imagination part of the brain, the picture part of the brain, in ways you create pictures of the world. And so, as I mentioned before, each part of the different part of the brain inhibit the other parts of the brain, right? So if you have damage to the left side of the brain, what can happen in some people, and we see this in patients all the time, they may grow artistic talents and become really good painters, right? So their visual imagination and stuff like that becomes incredible. Yeah. So by imagining things, and I just want to tie it to what you're saying, which is that whenever you see yourself in a situation and you have visual imagery, you engage some of these spatial centers in your brain. And the more you use them, the more they will expand and become more powerfully wired. Now, if you see yourself, if you close your eyes and imagine yourself, kicking a soccer ball and seeing it go into the corner, and you kick it in your brain, it turns out you use the same circuit as if you were awake. Do you know that? And
so it's just like you're actually doing it, huh?
Like you exactly do. So so this is interesting. So when I sit down now and I close my eyes, I imagine myself doing anything, I engage that circuitry. So you can have plasticity occur in your brain if you attentively focus on something and you see yourself doing it over and over. In fact, that's why we go into dreams later, I expect. But in dreams, when you see yourself doing something, what happens? You activate those networks and lay down those circuits. So it's very similar.
So you wake up, it's like you felt those dreams.
you felt them and you did feel them because you were enacting those circuitry as if it was real.
Wow.
So there's definitely, and then you would have that expansion of that part of the brain. Does that make sense?
It does, yeah. So if I were to have an important presentation tomorrow, and there are two kinds of people who are trying to go in and try to wing it, and there are people who will practice,
Yes,
put themselves in that situation,
yeah,
and put themselves in the anxiety of the situation, because that, I wouldn't say, it's a big presentation with 1,000 people of the industry and top-notch people.
yeah,
Let's say the best neuroscientists, right? So you imagining you being in that, obviously there is experience where you get used to that feeling, those feelings, and you get used to them. But I'm trying to help people here who walk into difficult situations, whether it's playing a game or walking into a big presentation. So imagining you just saying the presentation is not enough, I would say, and maybe you can correct me.
Yeah.
What I would do is I would imagine myself in the moment and the anxieties of the moment, and try to build adaptation to those feelings.
Yeah.
So when that moment comes, and I would also try to inflate that moment and make it super anxious. I do things like that sometimes to prepare myself before a talk.
Yeah.
And when I come to the talk, it just feels like I've been there before.
Yeah, so there's definitely different components to it. Like, how do we prepare optimally for like a talk or a lecture or like an interview or something like that? And definitely your brain has this, the circuitry in the brain can be trained in various ways. One thing is that your brain is super context dependent, meaning that if you literally want to learn more, it's been shown that if you go to that environment where you have the exam. So when I was at the American University in Cairo, I used to live in Cairo. I told you. Did I tell you? 4 years I lived in Cairo.
Yeah.
And أحيانا ذهبت إلى الجامعة الأمريكية الجامعة بتاعي, and I would go to the class and sit there and then do the homework within the classroom itself. I became very hyper focused on studies.
So you would go there.
I would sit there, and then
to where the exam is going to be conducted.
Yes, and I would do my study. I would learn there because I know it is context dependent. So that's one example of how to.
So you got used to the environment. So how did that reflect on the exam? So you just felt more comfortable?
I felt comfortable. I first of all, I learned the information in that room, and I knew the exam would be that room. So I went and studied and did the repetition in that room. So that could be an example. So if you have a big talk in a certain lecture hall, go into that lecture hall and imagine the audience, for example. If you,
But look, there are two kinds of people, and there are people who, in big situations, they show up and they become bigger, and there are people who crumble.
Yes.
You'll see them very anxious. They'll forget the words. They won't do well in the exam, or they, in big moments, like you have. Like I don't want to name players, but they are basketballers, football players, known that in big situations they shrink.
They shrink.
What happens in the brain?
It's a great question. I love the question. You see, Messi, he shrunk in a few situations on the finals, with the penalties and all that. You saw that, right?
Yeah, like the first final.
Yes, he did. And I think so. What happens is, definitely there's a lot of personality components to this. What is your personality? Do you crumble under pressure? Can you reduce stress? Cristiano Ronaldo is an example of somebody who can totally just, he will reduce all the fear and just be very clinical in those moments. You know that.
Yeah. He'll use the pressure.
He used the pressure
from the audience, from everywhere.
But I think it's not really only or mainly using the pressure. What I think is inside the brain, what's going on is Messi is probably he's less able to inhibit his impulsive and emotional part of the brain in this case. So there's a part of the brain called the limbic centers. Behind the ears, I mentioned before, it's actually a bit deeper, but in that area, it has to do with emotionality. So that part of the brain is inhibited by the prefrontal lobes. And so the more you have circuits going to the prefrontal, from the prefrontal, the medial, here also the DLPFC, both entire prefrontal, if you have a lot of fibers and have a lot of inhibitory circuits going back there, you're able to, in key moments, inhibit fear. Inhibit fear. So a psychopath is an example of somebody who doesn't even need to inhibit it because it's already, the activity is not there. But I think Cristiano is probably, and I would venture a guess, I don't know, but he's probably somebody who's just less emotional than Messi overall. This would be my guess if I had to make a guess why Messi couldn't He shrunk in those moments, whereas somebody like Cristiano was just super clinical and just scored. And I think that has to do with he just feels the pressure. When I say emotional, doesn't mean he goes around, he's a wreck or anything. I'm just saying that the pressure he felt from the Argentinian fans of being somebody who can lift Argentina and be the new Maradona, it weighed on him. It was such a burden on him that he could not inhibit that emotional core from his prefrontal lobes, and so that it just took over. Yeah. And now the question is, how can you and I benefit? And I think it's having a strong sense of discipline, being,
So a strong sense of discipline gives you resilience in
all situations. So the brain generalizes, meaning, so if you can learn to inhibit your impulses and your emotions generally, that will help you in key situations as well. In other words, let me give you some concrete examples. Baland wakes up in the morning. Yeah. He has a strong urge to reach out for his phone. It's right there. He wants to check Instagram or something.
Story of my life.
Exactly, right? All of us. Yeah. Now, Baland does the following. He says, I have the urge, but I will not act on that urge to go check my phone. I'm going to wake up, in fact, and then I will do something more productive. I'll go and
take a walk.
Take a walk, right? So I'll take a walk. And I've had periods of my life where I've reached for the phone and then periods where I didn't reach for the phone. But I sometimes, and I do this now, it's not reaching for the phone at the moment. It might change, but at the moment, right? Yeah. I do not reach for the phone because I know by not reaching for the phone, I'm training my prefrontal lobes to inhibit impulses. I teach it how to inhibit impulses, and I strengthen that part of the brain and that circuitry. Now, the example, my dad, he's about 70 years old. He's a great guy. I love my dad to death. He's a beautiful guy, but sometimes he gets mad at me, and
just like any other dad.
Like any other dad. And of course, this is in his right, because I can be a very, very poor son sometimes, right? And he says, why don't you do that? Why do you do that? You should do that. And I inhibit my emotionality. I go, look, this is your dad. Treat your parents with honor and lower your wings of submission and humility to your parents. Be humble to them. Yeah. Do not reply. Do not say, uff, la taqul lahum uffin wa la tanharhuma, right? Don't do anything of that sort. Just stay on course and just be humble. And sometimes, I train myself to do that. And then what happens? 1 time, 3 times, 5 times, I don't do anything. And then I go out in the street and somebody shouts at me, and I have learned now to inhibit my emotionality and impulses and be less aggressive overall. And doing simple acts like this in your life,
they go a long way.
In fact, they can help you on that dress rehearsal because now you've trained your prefrontal to inhibit impulses and emotionality overall. Your brain is like this. Your brain is very generalized overall. If you have anxiety in situation A, right, it will trickle into other parts of your life. We talked about, you mentioned love briefly. If you're anxious in your life overall, you'll be anxious with the girl as well. And you'll be anxious on the exam as well. Okay. Of course, there are specific anxiety triggers like social anxiety, and all that. But anxiety generally is it's very broad as well. And it can trickle into all these aspects of your life. Your brain is not that specific. It can be, you can have a phobia, but I'm saying at the same time, if you can teach it to be disciplined in scenario A and B and C, with the phone and with your parents shouting and all that, that will trickle into all the other aspects of your life.
How important is discipline to our personality?
That's very, very important. Now, discipline, there are layers to discipline. Meaning, yes, you want to have discipline. You want to be focused. You want to be able to do your stuff in life. But being hyper-disciplined, in fact, can also be a bad thing. You have to have flexibility in the system as well. Meaning sometimes it can be advantageous to be not non-disciplined. Meaning,
how?
By non-disciplined, I'm kind of using that term broadly.
So flexible, I understand.
Flexible,
but how is it advantageous to be flexible sometimes?
So let's say somebody's shouting at you, hitting you, spitting at you. You're disciplined, okay? Turn your backs on them. Say salam to them, okay? Don't even walk on the earth humbly, and don't shout, right? Don't do anything, okay? But occasionally turning around and just facing your bully, your predator, and saying, look, the hell with you. We talked about religion before. Prophet Muhammad sallallahu alaihi wasallam, they threw all these things at him when he was praying near the Kaaba, right? They bullied him. They did all this to him. He didn't do anything. First time, 3 times, 5 times. But at the end, one time, he just turned around and said, look, I'm going to beat you all up. I'm going to just do something to you. And they all froze and they said, oh my God, what happened? They got scared. And they didn't do that. They stopped their bullying. So once in a while, standing up for just yourself can be a good thing.
I see what you mean. I see where you're going with this, yeah.
Yeah, so what I'm saying is that...
Do not get too stuck and too sucked into...
Don't be disciplined and hyper-inhibited. Okay. Hyper-inhibition is not a good thing. Sometimes, somebody comes into your house and, trying to kill your family. You don't want to be disciplined and not do anything. I'm using discipline in a broad sense. I'm using it in a neuroscientific sense as an inhibition and staying on course. Sometimes you want to rear away from the standard course and do something spontaneous or impulsive because it's better, it's more advantageous for your overall well-being, right? Another example, once I was in Cambridge. I used to live in Cambridge, as you know. I was walking in the street and this guy, I'm not, as you know, I'm pretty down to earth overall. I shouldn't say that, but I don't like shout at people, do anything. But I was walking with my mom, and this guy was trying to. There was like a few young guys, and they did something. They kind of looked at my mom and said something to her.
Does she wear a hijab?
She didn't wear a hijab, but they can see she's Arab and she's Kurdish, but from the Arab part of the world. And they looked at her and they said something, and I turned around and and they saw that I was ready to beat them up.
So they saw it in your eyes.
They saw it, and I kind of looked like I was ready to beat them up.
Yeah.
And that's why you say that's where discipline wouldn't. The hell with discipline, like they just insulted my mom.
Yeah.
They insult my wife. For example, I'm not married, but let's say they insult my kid. Once you stay disciplined but you also sometimes go away from discipline once in a while and just be a man and protect those whom you love and protect yourself if you need to do so. But obviously, I'm not advocating violence here, but I'm saying discipline.
You are advocating violence, man. No,
well, I'm advocating self-defense.
No, you're advocating a very balanced and dignified person.
Absolutely.
I think that's very important for you to not to overdo discipline where you're hurting yourself, rather than using that discipline. Maybe that's where emotional intelligence comes in to say,
yes,
this is a situation where I need to stop discipline and just go out of my way.
Yes.
Another thing is we spoke about love, but we never really got into it. Yeah. So what is true love? We have an Arabic saying, Imam Shafi'i, عين الرضا عن كل عيب كليلة وعين السخط تبدي المساوية. Where what happens, what it means is when you love someone, they can get away with anything. But when someone that you dislike, you just don't like the way they breathe, more or less, right? We all know people that for some reason I don't like being around that guy or girl, and vice versa. Yeah. There are people you just want to be around, and whatever they do is fine. Yeah. I can forgive them for anything. Yeah. So how does that work in the brain?
It's a great question. So when you have love, first of all, you have different types of love. So you have romantic love, obviously, and you have more sort of parental love of your parents. You have spiritual love, different types of love. Yeah. Love to your children and so forth, friends. Let's talk about romantic love. Let's talk about that. So I didn't know much about love until I got assigned a course at Peterson Academy in the U.S. They asked me to do a course on love. I was just surprised because I don't even know how to talk to like females or anything. I'm very clumsy and awkward, and so I got a bit surprised. But then I was surprised. I was happy to read about the neuroscience of love and learn it and teach it because it's so fascinating. And interestingly, in romantic love, first of all, there are different stages of romantic love. Initially, there's obsession, infatuation. That's the kind of passion you have, and you see in Titanic, for example, in Jack and Rose.
Like the honeymoon.
The honeymoon stages, right? Yeah. So this is the first, 3 to 6 months.
So that's true in neuroscientific.
Yeah.
Really?
Yeah, the brain completely, it changes its function. The functionality of the brain changes. So the prefrontal lobes that has to do with rational thinking, and we mentioned the guy who had the iron rod change his personality. That part of the brain shuts completely down when you are in love. That's why you do rational things. You show up like a different place, and you to see the girl, and you do all kinds of adventures, and you try to impress her in all these irrational ways, and you go, my God, did I just do that? That was so bizarre. That was weird. That was embarrassing. But you're willing to do bizarre things because you're in love, right? So the prefrontal cortex shuts down. And that's even why you say, okay, her flaws, it doesn't matter. She's extremely sort of does bizarre things, and she might even shout at you, and you just that's fine. She's not a bad person or whatever, right?
But maybe the best way to put it is someone after an exercise, they smell bad, but that's fine.
Correct. Yeah.
Yeah.
So that's the prefrontal lobe shutting down. Then you have the TPJ part of the brain is part here. It's involved in things like self-other distinction, knowing that you are Faisal and Baland. There's a barrier between us. That part of the brain also shuts down. It's also involved in empathy. It shuts down in the way that there's a merging with the beloved. So you feel like you're like a unison. You're like one team. That's another change in the brain. And there's a clear-cut center of the brain that changes when you love. Dopamine fires away. So you have tons of dopamine in the system. In fact, the brain of somebody who's in love very much looks like a brain of somebody who's on cocaine taking crack.
Oh, wow.
Yeah, it's like super sensitized to anything in the world. Not only is the beloved beautiful and, magisterial and magical, but the whole world is beautiful. There's a globalization where everything, the neurons in the brain, the mesolimbic cortical circuits there, become sensitized to anything in the world. So they are just fired more easily. Even pain itself becomes less painful. Like if you're putting your hand in the ice water and you think about your beloved, there would be less pain now because because of the endorphins and all the pleasure centers being hyperactive in the brain. So you have that. Interestingly, serotonin in the brain, which is involved in things like well-being and mood, it actually goes down in the first initial stages, which is counterintuitive.
Yeah.
But it goes down because it's hyper stressful in the initial few months. It's stressful. Will she stay? Will she, go away? There's all this uncertainty in the romantic courtship initially, right?
Yeah.
And so that makes serotonin goes down. In fact, serotonin is low in OCD. So that's why in the initial stages of love, you have a lot of rumination and OCD like loops. You think about the girl all the time. Like you're going around thinking about the brain, and
you're waiting for that text message.
You're waiting for the text message, and then she pops in your brain when you're just playing tennis. You go to your parents' house and have dinner. She pops into your head again, and she's just all over. That's the ruminative part of the brain. The circuits going from medial to the basal ganglia for the nerds out there who wants to know. And then the serotonin centers going down, and so you become hyper obsessive. So you have that. So dopamine goes up, serotonin goes down, prefrontal shuts down, TPJ shuts down, right? So you have all these parts of the brain. BDNF goes a bit up, so you have plasticity now because your brain goes from before life was all about Baland and Baland's own selfish life, and now I have to integrate another person into my life. I have to be less selfish. I have to be more open to her mind and perspective as well, and kind of incorporate her into my sense of self. So BDNF, you have tons of it, which is counterintuitive because cortisol also goes up. That's why love is hyper stressful in the first few months. So you have this paradoxical state with cortisol going up and serotonin going down, dopamine going up, and all this and noradrenaline, the hormone involved in the sort of your heart racing and sense of sweating and all that.
Butterflies
goes up as well. So it's a beautiful cocktail. In fact, hormones involved in attachment and bonding called oxytocin and vasopressin. These are certain neuropeptides involved in things like attachment and bonding. They also goes up. But in fact, they go up. The longer we've been with the girl and the more we've sort of built a sense of trust and intimacy, the more it goes up. So these are the attachment parts of the brain. Does that make sense?
Yeah. So oxytocin and what's the other one?
Vasopressin.
Yeah. They're responsible for
sense of bonding. So a mom, when she has a little baby and she's connecting with that little baby, she has tons of oxytocin in her system, and it's released so she can bond with that child. But we also have it with.
So that happens for the first 3 to 6 months. So love at first sight can be true.
Oh yeah, love at first sight can be. There's tons of truth to that. Not always, but it can be true. In fact, they have shown in science, there's been a study showing that if you show a picture of a female, I'm using female as an example because I'm a male, so a female here, and I look at this female, and if in the first half of a second, if I look at her face, that's an indication of romantic interest. But if I don't look at her face and look at her body, that's an indication of short-term mating interest, if you know what I mean.
Yeah.
You're not interested in it's not love at first sight, it's sexuality at first sight.
Yeah.
It's you wanting something different. So this is actually a crucial point, the fact that whether you look at the face or you look at the body. Now imagine this for dating apps, by the way. If your dating apps could decipher track your eye movements and know how you are looking at the female, what your intention is, and you do have in your brain, you have different circuitry for short-term mating intentions and long-term mating intentions. And now in this part of the world, mashallah, it's more the long-term intentions that usually goes into the equation, but long-term, but often short-term intentions goes in.
And this is why I like the concept of غض البصر, or not really looking at a girl for a very long time, because back to my 20s, early 20s, when I tried thinking of different little habits,
yes,
and just shying away from the ones that I just feel that they're not right.
Yes,
it made me focus on myself a little bit more and kind of building myself. And one of the main things that helped me a lot is when I look at a girl, I just don't stare. I just
lower your gaze. Lowering
the gaze.
There's one of the most gentlemanly thing you can do is lowering your gaze, and we'll get into that in a second. I just want to, before lowering your gaze, I just want to complete that thought, because I think it's important in terms of short-term and long-term strategy. If you are a female, and I see this is a lot in Europe, if a female is interested in Baland, let's say, or not me, but somebody else, right? Using her body as a way of getting his attention is the worst strategy she can use if she wants a long-term partner. But yet you see it a lot in a lot of the situations that I've seen in my life, that where female will use their body, they will use their skin, and they try to attract the male.
Because it'll interpret the brain of the man will interpret it differently.
Because the female has learned that by getting a man's attention, they can get it by showing their bodies. Because the man will look, the man will stare in most cases. I'm not talking about you, but in most parts of the world, men will stare.
Yeah.
This is human nature.
Yeah.
And she has learned that she can get male attention in that way. But if she wants the man to intend long-term relationship with him, she shouldn't use her body. She should, in fact, use her personality instead. I know that in the beginning, in the first initial, when you look at a woman, yes, you do want to know how she looks and all that. You have an idea of her shape of the body. I'm just being honest. Sorry, I don't want to be. But that's
fair.
That's fair, right?
Yeah.
But my point is, being immodest for a woman, thinking that this is going to get a man to love her, which a lot of female may think, this is not the case from a neuroscientific perspective.
Not true.
Not true.
What will happen instead?
He will go more for the short-term parts of the brain will be activated. He will want to have a short-term relationship with her. If he's living in a country where that is acceptable, right? He'll just want to be with her for a short time. So this is not the way to go about it. Now you can do something else after.
So no, lowering the gaze. But before we get to that, so the long term. So, so that really plays into a conservative way of presenting themselves in terms of women, and that's why I think there's so much elegance in a woman.
It's elegance.
In a woman that presents herself, that she puts more attention into her personality.
Absolutely.
And on the top part of her body, rather than trying to because again, there's something unnatural about it, and we all feel it as men and women. We all feel that there's something unnatural, something off about it.
Yes.
And when you look at the neuroscience, and when you look at it scientifically, and it makes sense, it gives me confidence to really want to stay there,
Yeah, no, but this is human nature. And if you look at any movies that portray true romantic depth, whether it be Titanic, I just saw that recently, it was on TV in Copenhagen, for example, is running there. And, Jack, the character, the protagonist there, he never sort of stares at Rose's body. He's into her personality and character, and obviously her face initially is attractive. And I'm not saying that he doesn't find her body attractive, but I'm saying there's a romantic depth there that's beyond the physical and the sexual.
Yeah.
And I think that's important to know that distinction between long-term and short-term strategy. But let's flip it aside, because we don't want to be too hard on the women too, because males stare. Males, they want to be macho. They want to be red pill. They want to be hard. They want to be all these things because they think that's the way to get a female.
Alpha.
All of it is nonsense. All of it. It's
really?
Nonsense. It's nonsense. It's nonsense in the sense that, yes, you want to be masculine. Obviously, you want to be decisive, masculine, but you also want to be emotional and kind. And in fact, the research shows that females, for long-term partners, prefer men that are kind, that are gentle, that are generous,
considerate,
that have considerate and all that. And not staring, lowering your gaze is one of the most charming and charismatic things you can do, because it is really about what females respond to in the scientific sense of it is obviously looks and all that. Females are attracted to males that have certain features and that, that look certain way, obviously.
Wide shoulders, whatever.
Wide shoulders, big chest, sometimes there's actually that is difference. If they are ovulating, the lady's ovulating, she'll like more softer features, like a softer kind of look, and more masculine traits when she's ovulating. I think, it's either, yes, when she's ovulating, she wants more masculine traits. So there is that. But generally, what I'm saying is, in terms of the initial, so you have the initial attraction. So you're attracted to this guy. You don't know why. There's other factors, by the way. It's not only ovulation and masculine. There's other factors. We can go into that as well. But learning from your childhood, you saw a guy that looked like somebody that, had some certain, it can go deeper, much deeper, how you find somebody attractive. But once you find them attractive, like once the lady says, okay, this guy is attractive, I like him, he's tall, he's, he looks good, he's good looking and all that, then what goes into the picture now is his personality. And from a scientific perspective, what I mean is prefrontal integration and in a sense, how well does his brain prefrontally inhibit his impulses and his emotional core? How integrated is he overall? And staring and being impulsive and being somebody who's erratic is definitely not something that will turn on a woman. And most guys know this, right?
So a woman would prefer someone who's more balanced and
staring, for example, is an example of not being able to inhibit your impulses. So being a gentleman and lowering your gaze is one of the most charming things a man can do, I think.
That's something that's very interesting.
It's interesting because there's a whole there's attraction. Why do we find certain people attractive? Why is Johnny Depp type personality attractive? The Bodyguard, it's tons.
It is like the Johnny Depp type of
character. He's
non-alpha.
Why is
non-alpha and he doesn't care, not caring. Sometimes a guy that doesn't care is very attractive.
Very attractive, yeah.
Right?
Absolutely.
See, we're speaking about hormones.
Yes.
And we're going to take another path of hormones.
All right.
DMT hormone.
Okay.
So I'm just gonna, and then you can correct me if I'm wrong. Okay. So the DMT hormone is the hormone that gets secreted near death experience or someone's like close to dying.
Yeah.
And then some people will say, I've seen the Sharit Hayati, which is what is it? I saw my life before my eyes,
sure.
All my memories.
Yes.
So what is this DMT hormone and what happens when someone goes through a near-to-death experience?
Right. So it's a very interesting question. What is DMT doing? You have endogenous DMT. I think it's released the pineal. I haven't looked at this particular hormone for a very long time, but it's involved in some of these very very mystical experiences. And in fact, you have circuits in the brain that seems to be, you have mystical circuits in the brain, and things like DMT, things like mescaline, psilocybin, and all that. They activate a part of the brain and a receptor of the brain called the serotonin 2A receptor. There's a fancy a way of saying that you have serotonin in the brain, and then you have certain, on the cells, you have parking spots, and one particular part of a type of parking spot is called a serotonin 2A receptor. And that when it's tickled by serotonin, you have a mystical experience. And by the way, in the emotional part of the brain, the amygdala and limbic emotional brain, there's tons of these, as you can imagine, because spirituality and mysticism is a very emotional thing. So these hormones and these chemicals, what they will do, they'll activate some of these receptors, and then you have spiritual and mystical experiences. So what's going on in the brain? Why do you have that? We don't know exactly why we have them. They seem to be active when we dream as well, but they just change the fabric of reality and how we perceive it. So we do have mystical circuitry in the brain, the spiritual, mysterious type circuitry, and they have a particular pathway using this receptor. If that makes sense.
Yeah, it does make sense. And then when we speak about spiritual, mystical receptors, are they affected when someone prays? And how does spirituality comes into it?
100%. So the limbic part of the brain here, right, behind the ears again, and that area. In fact, there was a helmet in the 1990s by this guy, Michael Persinger. He would use a helmet, put on these guys' brains, and then he would zap it, and he would zap the limbic part of the brain, and they would have mystical experiences. They would say, God is in the room. I had like a presence of God. There was a mystical divine angel over there. So they would have mystical experiences from activating the limbic part of the brain. Or if you have epileptic seizures. So you can have seizures in the brain. They can be epileptic, they can be focal seizures, or they can be grand mal seizures where you kind of lie on the ground and all that. But in specific type of seizures that affects the limbic part of the brain, the emotional part of the brain, you will say, oh, I felt like God was talking to me. I had prophecies. And these guys becomes hyper poetic, suddenly recite, Shakespeare, all of a sudden start writing their own poetry. They become hyper religious. They become completely disinterested in sexuality. No sexual interest. Just everything is just God, poetry, all these kinds of things. Bizarre, strange, but their personality.
They lose interest in material.
In the material part of the world, and yes, in material things in the world, absolutely. So you have that. That's temporal lobe epilepsy, and that's really creating a. So if there's a part of the brain where all the interesting stuff comes about, is in the limbic part of the brain. In fact, I would argue, and Ramachandran argued this before me, that in the limbic part of the brain, that's very much where consciousness, in a sense of not only God and passion and all that, it's really in the limbic centers where it all happens. So let's zoom in on the limbic, because it's so fascinating.
So the limbic part is on the...
Yeah, the limbic center is right here behind the ears, deep inside. There's a limbic core, and it's like a ring-like structure. It has the amygdala, which is involved in fear processing, but it's also involved in positive emotions. So it has multiple functions. It has something called the septum. When you simulate that, people will have sexual experiences. So they have deeply sexual experiences. So
you can zap someone's brain,
yes,
in a way where they'll just feel
insert it, and they will feel like they will complete the experiment to not stop the experiment. They keep zapping me. Okay? That's the septum. It has the hippocampus as well, the memory part of the brain. So it's all hooked up in that circuitry. But in that circuit, as we said, a lot of it seems where in sense of meaning and everything comes about in that circuit, in sense of glow to the world. If you have what's called Cotard syndrome, you will say the whole world is dead. I feel like the world is dead. I am a dead man in the world. The doctor will take a needle and poke his hand, and you will say, my God, the doctor said, your hand is bleeding, Joe. And you'll say, but I'm dead. I'm a dead man, walking. And he'll say, well, how can a dead man bleed? And he'll say, well, maybe they can bleed after all, he'll say. All right. So in other words, he's completely just like, I am dead and the whole world is dead. And the reason why he says this, that he says, I am dead and the world is just, I'm just a dead man walking around in a deadly world, is because the limbic part of the brain the activity there has flattened.
So lose sense of life.
Life itself becomes entirely bleak and, deprived of meaning and purpose. And you feel like a dead man walking. In fact, depression is kind of similar. Now, Cotard syndrome is like depression on steroids. It's like 1,000 times more deactivation. But in depression, because of the lowering of activity in those centers and in dopaminergic centers, you feel like the whole world is also kind of dead, and it's kind of like, it's cloudy. Not maybe dead, but it's cloudy, and there's not much meaning. I want to correct one thing. So if the circuit that goes from the limbic part of the brain to the facial recognition part of the brain. So in the brain, you have a part of the brain involved in vision, seeing the world. So this is the back of your brain involved in seeing reality. Now, the back of the brain is actually only involved in seeing things like shapes and lines and simple things. Simple things happens in the back part of the brain, the occipital lobes. But then as information travels and hits the eye and goes to the occipital lobes, it travels up here to parts of a hierarchy, creating more sophistication in your visual percept, if that makes sense. Does that make sense?
Yeah.
So, for example, when I see this beautiful gold camel over there, right? First I see it, lights hit the eye, and then it goes to the initial visual part. I have a shape, and then it goes to higher parts, and I create, for example, I have depth to it, and there's a part of the brain called the V4, I give it color, and then there's a part of the brain called MT, give it motion. If it's a static camel, but if it was moving, I will give it motion. If it's a screen, so there's a motion part of the brain, and there's a part of the brain called the, for example, the facial recognition area, the FFA, and I'll recognize its face and so forth. And even there's a center going, and there's a line going to the memory part of the brain saying, oh, I've seen a camel before. This is how a camel is supposed to look like, and it feeds back into the circuit.
So that's how we make sense of what's happening.
How we make sense of the world. So when I see a table, and I see this table, my brain doesn't go, oh, this is a table, let me create this table from scratch. I'm going to look at every part of it and then just create a new table from scratch. No, it goes, oh, here's the sketch. And then I'll take it back to the hippocampus all the way up the ladder, and then at the hippocampus I say, oh, I have this little part of it first and say, I've seen a table like this 1,000 times, and I'll just create from memory what a table looks like. This is the whole hierarchy. Now back to the original point, but I lost my thread, what we were talking about before we went to the whole...
You wanted to correct something, and then...
I wanted to correct something.
Yeah.
So my point of all this long-winded way of saying, and I wanted to add some little bit of neuroscience knowledge here. That's why I put it in here. So that's the whole visual hierarchy. Now, there's a fusiform face area of the brain, a part of the brain only involved in recognizing faces.
Yeah.
Only faces. So this is when I see your face right now, that part of the brain lights up with activity when I see your face. It's an interesting structure. It connects with the limbic part of the brain. It has a straight line and a circuit. If that center is hyperactive, okay, if it's deactivated, that's when you look at the mirror and say, I am dead. If it's deactivated, so the line between the face recognition area and the limbic center. So you have to have the limbic center being somewhat deactivated, and then the fusiform face area and that line being deactivated, that's when you look at the face and you say that I am dead. Okay, so, do you see the difference? So it's not. So if the limbic center is just shut off itself, it's just the limbic center is completely down. You say the whole world is dead. If the facial recognition area and the limbic, the connection is down, you say I am dead. There's a different. Sorry, I know you want to say something. There's also a condition where you go about in the world and you say everybody looks like my Uncle Joe.
Yeah.
So you go into the mall and you say this guy looks like my Uncle Joe. This person over there looks like my Uncle Joe. And this guy over there looks like my Uncle Joe. Okay, this is called Frigoli syndrome. It happens when that line between the face area and the limbic center is overactive now. And so the whole world, all the faces in the world feel familiar because of the emotional ignition there. Does that make sense?
Yeah, it does. So because it's over, it's hyper.
Yes.
So it's all interpreting all more or less
all the faces
the same
are familiar
thing.
and
Everything is almost the same thing.
Yeah, all the faces feel warm and fuzzy inside, so they must be my kind and warm Uncle Joe, and then your brain jumps to the conclusion.
But where does memory come into all this? Because I know people who have a really good memory, they're able to put someone's face and name together, and people like one of my colleagues here, he tells me he's really bad with names. I think I'm okay. Yeah. I'm less than average, I think.
Yeah.
But I know people are really good at putting names and faces together. Munira is one of them.
Yeah.
She's really good at just looking at someone and just say, oh, this person is this guy that we met a year ago.
Yeah.
Inshallah.
Yeah,
so what's inside her brain that's making her
names
very
and
powerful?
Faces. It has to do with it's a good question. My answer would be there's a condition where you do not recognize faces. It's called prosopagnosia. and I'll get to your question directly, but this is a condition where you literally go around the world and you do not recognize faces at all. So you cannot put any name on any faces. I had a friend, knew somebody, her name is Oliver Sacks. Munira, do you want to look Oliver Sacks up? Now we can use our skills a little bit. So Oliver Sacks was this great neurologist, and he was played by Robin Williams in a movie. Great guy. I got to know him from Mashandran as well. I know him personally. We exchanged letters and all that. Really warm and humble guy.
Yeah.
So he had prosopagnosia. So he would walk about in New York, and once he ran into a man, and he went like this, and he saw, oh, there's a man, and just jumped back, and he says, and then he looked at the man again, and Oliver did like this, moved his head, and the man also moved his head, and he did like that, and the man also moved the same way, and then he realized, my God, this is actually a mirror. I'm looking at myself. Because he cannot recognize faces,
he thought the guy in front of him was him.
Yeah, he thought he was a different person, but in fact it was himself looking at a mirror.
He couldn't even recognize himself.
So exactly. So whenever
that's him, huh?
So yes, this is him. So whenever he sees me, for example,
yeah, how does he recognize you?
He doesn't recognize me. So only by telling context, a name, and all that, then he'll recognize me. But if he sees me, he will not recognize me. In fact, if he sees his own brother, he will not recognize him initially.
He wouldn't recognize himself. So
that's a good question. So
what happens to some people lose some? Okay, so it's that doesn't have to do with
that's the extreme example of not knowing any faces, right? That's the extreme example of that. But to your point, how come some people are
some just better memory, maybe
not memory? Because what is memory? Memory has so many dimensions, right? It's not memory. Memory. So as you said, there's like 4 or 5 types of memory, right?
Okay.
It's
it
has to do with facial memory somehow, and the fusiform centers going. And this is me speculating because I'm not sure of any scientific studies looking at how come people remember faces better than others. I'm speculating has to do with facial recognition area of the brain and its circuitry to the more sort of long-term storage hippocampus and the those areas of the brain. I think it has to do with that circuit without having completely knowing completely.
What about memory in terms of experience? Some people they will retrieve it. Like when we look at witnesses, and we look at a case study or a court case, and you'll see someone who will describe the situation in detail.
Yes,
and they'll tell you, because I can say, Baland came to Kuwait,
yes,
and I'll say he came to the office or he came into the studio, and then he sat down. And then we just started the interview. And then, or I can say, Baland came and then he asked me, how are you? And then he said, are you okay? Or is there anything that I can do to make this conversation better? And then he sat down.
Yes.
That makes people think of you differently, right? And there are some people in the same situation.
Yes.
2 friends fight, and other witnesses are there.
Yeah.
They'll have a different view on what 2 people have witnessing from the same angle, but will have a different story to tell.
Yes.
Why does that happen?
I think we're getting into two different things in some sense, because there's one, and correct me if I'm wrong, there's one is the sense of memory that's biased by your emotional circuitry. Meaning if you have a negative outlook on life, if you are somebody who has a high activation in the amygdala and the fear parts of the brain, and you generally are more, you are more negatively biased, then that will bias your memories too.
So if you're a person, if you know an example, Yaman was telling me, one of our producers,
yes,
he was telling me about the milk situation. I forgot what the exact name of it. I think spilling the milk. If you spill a cup of milk,
yes,
you have 2 people in the room. Someone will go, oh, you spilled the milk, and then someone else will be like, yeah, we spilled the milk, so what? Let's just clean it up.
I'll tell you, exactly. Yeah. And I'll tell you something, Faisal. There's actually brain circuitry for this. So if you have a baby, and as the baby is born, you take the baby and you give it sugar, the left part of the brain will be hyperactive. The left DLPFC will be hyperactive. If you give it like a lemon, a citrus fruit or something, the right part of the brain will be active. A 5-year-old, you show him something like a nasty picture, something dangerous on a movie, right will be active. You show him something, Charlie Chaplin, left will be active. Okay, adults as well. So we have this left and right asymmetry in the brain. The more left is active, more positive emotion. Right, more negative emotion. And of course, emotionality is not in the prefrontal lobes, but there are direct wires from the prefrontal DLPFC to the emotional parts of the brain. And this is important. Why is it important? It's important because, well, let me give you a final example and tell you why. Final example. If you actually have a stroke to that, this is how this is covered initially. If you have a stroke to the right side of the brain, the DLPFC, right, so the left hemisphere, what happens to the left now? We talked about antagonism.
Yeah.
The left now, you become manic. So I mentioned positive emotions is in the left side of the brain, but if you get a stroke in the right, you will literally become manic, hypermanic, and you will just laugh at a funeral. Okay, start doing the bizarre and happy things when you're supposed to be sad. And on the opposite, if you get a stroke to the left part of the DLPFC, the right flares up, and you become hyper sad and catastrophic, and everything is dangerous, and the whole world is frightening and terrifying. So you have that, and obviously, as you can guess, in depressed people, you have what? Tons of low left and more right.
More right, yeah.
Right, and there's studies shown there's up to 3,000% differences between individuals. So some people will literally have more activation in the right, more right versus left, and this can vary up to 3,000% between people. Right, so you can have huge differences. So I may be a completely left activated person, and Ali over there might be completely right. But the good news,
but Ali would be more, let's say, negative in situations.
He would then be much more negative in situations.
But can Ali change? Because we know a lot of people we're stuck with them, family.
This is the key question, and it goes back to all the epigenetics and all that stuff. Because epigenetics can change that whole thing. And yes, studies have been done that you bring children into the lab, and you'll see this guy. You measure his brain activity. Definitely left is much more active. You measure that, and how do you know as well? Left is active, but you also measure that in his personality. He's much more approachable with like toys, and he plays, and he's just more happy. So you know that in all kinds of ways. Then you leave him alone for 10 years. He comes back after 10 years. Check again. Put it on. You see now the right has become active and his left is low. You say, "My God, Joe, what happened?" And his parents will say, his father had cancer. He went through all this trauma, all these bad experiences. Now his right has taken over.
So he naturally becomes more negative because of the circumstances that he had to live through.
Yes. Another person, different, opposite pattern, comes into the laboratory. He's shy, he's withdrawn, he's scared. Look at his brain. The right is hyperactive, left is down. 12 years later comes back. Left is all up and right is down. What happened? Well, nothing really happened. He just had good friends in school and had some good schoolmates and had a pretty good life. And he discovered that he was good at soccer, and he's pretty happy.
That plays into nature versus nurture, doesn't it?
It does, and it shows us that nurture has a huge role epigenetically, and then just in brain structure and function. As you can see, it literally just can change you in this way. So
changing the environment around you.
Oh yeah, changing the environment around you, changing your habits, changing your diet, changing everything. Look, I mentioned free will before, and I said, look, we have free will, but don't get me wrong. I don't think we have complete free will in the sense that any decision that you make at any point will be biased by your hormonal state. So for me, Baland, for example, about 2 weeks ago, I was at the gym, okay? I was at the gym, and a machine fell on me, about 50 kilos, and the machine was maybe 20, 30 kilos. It fell on my chest. Why did it fall on my chest? Well, when I came in, I was distracted earlier by something that happened in my private life, so I was a bit distracted, so I worked on the machine. Boom, it fell on my chest. I had rib fracture or dented rib or something, That means tons of cortisol will be released now. So the decisions I will make, I may get poorer sleep now. I'll have pain, poor sleep, high cortisol. And then later on, when my mom says something, and I had discipline before, now I may not have discipline. I may say something, and that will trigger a cascade of things that will happen. And then you'll go, did I really have free will or not? I do believe we have free will, but I do think that it's highly biased and tainted by our circumstances and our hormonal state. How much did we sleep? Under how much stress were we, and so forth. So it's all about trying to find the windows of opportunity and increasing the positive stuff by building more discipline, getting more rest, doing more exercise in order to avoid the more stress you're under and more pressure, the less somehow free will you have, I feel, because you become more impulsive, and impulsivity is not really free will. Free will is when you take action consciously,
independent of those
urges. Yeah.
And urges. So we've mentioned sleep and resting a lot of times now, and I think it's really a good chance for us now to understand why resting and sleeping is really good for your brain and rejuvenating.
Right.
They say sleeping is like a housekeeping service for the brain. Is that right?
That's a great way to put it, Faisal. I think sleeping has a lot of functions. So first of all, when you fall asleep, you enter, obviously stages 1, 2, and 3. So you have stages of sleep. So there's an architecture to sleep. 1, 2, and 3 just meaning, it's me being scientific, meaning that your heart rate goes down, your blood pressure, body temperature goes down. The parts of your brain, your cortex that has to do with awareness, the prefrontal lobes shuts down. The visual cortex actually becomes a bit active. That's why you start dreaming and having visual inputs and so forth.
So the visual cortex is still...
It becomes active. Yeah,
still active.
It becomes even active.
But the visual cortex, even if you have your eyes closed, it's still working. It can still work. Huh?
Yeah, it can still work.
But what feeds it?
What feeds it? It's internally feeded. So when you are awake, it's fed by input from the world.
Yeah, outside input.
Outside, external input. When you close your eyes and you go to sleep, it's fed by the lower parts of the brain. Here in the brain stem, you have something called, this is the medulla oblongata, and then the pons. And then here in the brainstem, you have circuits, you have regions involved in creating acetylcholine, and the PGO waves, they will light up the occipital lobes and other parts of the brain when you are sleeping. If that makes sense. So you have internally generated vision during sleep. Now, as you fall asleep, and if initially you fall asleep, go in stages 2 and 3 and 4, become more deeper and deeper, you hit deep sleep. Okay, deep sleep is completely interesting. It's a very interesting part of sleep.
How is it defined, deep sleep?
Deep sleep is a stage of sleep where you have entered a deep sense of sleep, and the activity of your brain, the waves, you have brain waves you can measure in your scalp, how the state of the brain will differ from the other stages. So when you are awake, you have something called beta activity. It's like, this is beta activity, right? And all the frantic waves tells you that there's tons of parts of the brain active at the same time. So the brain is hyperactive in this way. As you go into and as you fall asleep, as you mentioned, the first initial stages, there's a slowing down of waves. Everything just becomes slow and slowed down and all that.
Okay.
As you hit deep sleep, though, you have these big ocean waves, like boom, 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 coordinated patterns.
Wow.
Beautiful to watch, like so, boom, boom, telling you that far-flung regions of the brain have now become active at the same time. So different parts of the brain will become active at the same time. Far-flung regions. And then on the tail end of these waves, you have something called spindles, like these small waves. And these are telling you that the brain is now taking information from short-term memory, the hippocampus, and storing it in long-term memory, the cortical outside of the brain. So whereas that hippocampus part of the brain is more involved in accessing and storing memory, is not actually holding on to the memories as in long-term and keeping them for safe storage. So that happens in the hippocampus, and that is those little spindles. In this part of stage of sleep, all the beautifications happens. So I'm coming to this podcast. I want to look pretty for your podcast, right? So I want to have a lot of deep sleep. So skin regeneration, hair replenishment, cardiovascular replenishment, all these kinds of things happen in deep sleep. In fact, you have a system called the lymphatic system, whereby you have cells in the brain that are called glia cells. So you have neurons and you have glia cells. These are supporting cells. These will shrink about 20%
Okay.
A 20% shrinkage, allowing something called cerebral spinal fluid to bathe and wash your brains and clear all kinds of toxins and beta amyloids and all these things that can lead to misfolded proteins and potentially Alzheimer's in the future.
Oh, so sleeping prevents Alzheimer's.
Deep sleep.
Deep sleep, huh?
It does, yeah.
Oh, wow.
It can help buffer against it. Obviously, there's genetic factors.
Obviously, yeah.
Yeah, for it. But deep sleep is a way of clearing the toxins that can build in your brain.
So deep sleep works on the brain itself and replenishes and rejuvenates the brain, and also obviously the body just rests. Is it like so? So one would imagine that everything shuts off when you're asleep, but no one would think that things are. So your visual cortex theoretically never shuts down, huh?
So what happens is the visual cortex. It never shuts down. No, it doesn't.
So you're always awake in a sense.
So what happens is that the visual cortex is, I would say, it's partly awake as you are floating into sleep. Stages 1 and 2. There's a partial activation of the visual cortex, but it's not really until you hit the REM stage of sleep where you have a full activation of the REM of the visual cortex.
Okay, so REM is when you dream, right?
Yes. So this comes next. This is the like.
So the first thing is just the small beta waves becoming.
Beta is when you are awake.
Yeah.
Then you have the slowing of the waves.
And then it goes big.
Yeah, memory far-flung regions.
So the second stage is when it goes big, and then you get the small spindles.
And small spindles, yes.
Yeah.
It's like, think of the spindles as. Think of deep sleep as the librarian,
just putting the memories,
taking the information and filing them in safe storage, like a librarian in the brain.
Okay.
It's very, very, very simple in that regard. It's also involved in a lot of the redundancy of connections, removing excess connections of the brain. So your brain, you don't want to have excess connections in the brain. You want to have a lot of pruning, meaning like Faisal went about in Kuwait yesterday and he did all these things. You don't want to remember all these things forever. You want to remove all the redundancies. Happens in deep sleep as well. So you remove all the excess stuff.
So deep sleep will only keep hold of the important information.
It helps you keep hold of the important information. The deep sleep. And then obviously all the physiological factors we mentioned, cardiovascular, lymphatic, immune system replenishment and all that. Deep sleep. So you can imagine how important it is to get tons of deep sleep. And it turns out deep sleep, you have more of it in the first part of the night too. So it's important. But now comes the most interesting stage of sleep, which I love, which is REM sleep. This is REM sleep.
Dreaming, huh?
Dreaming sleep. So what happens is suddenly, from everything being slowed and everything being these coordinated waves, suddenly you have these fast wave, like beta waves going again. And you look at the brain and you say, this guy, is he awake? What's happening? What's going on in the brain, right? What's happening to this chap? For a long time, we wouldn't think that the brain of a waking guy and a sleeping guy would be completely identical. In fact, the guy who is in REM sleep looks more awake than the guy who's actually awake.
Wow.
Now you have adrenaline pumping, you have blood pressure rising, you have all these things that looks like a guy who's running, sprinting. You're having all that happening.
But just while asleep.
While asleep. And then you have the PGO waves, as I mentioned, firing up the brain with acetylcholine going up. You remember acetylcholine from before, the attention?
Yeah.
Yeah. It fires up the brain and it makes the brain hyperactivated. So you are now you're activating the visual cortex and fireworks there and other parts of the brain. Then you have another shift. You start to see motor regions of the brain, the strip of motor movement causing me to move my hands and legs and all that. That becomes active as well. So you have movement parts of the brain being active. Okay. The emotional part of the brain, 30% more active.
The emotional part of the brain.
Emotional part of the brain, the limbic center, about 30% more active now than a normal wakeful person.
So you're feeling everything 30% more.
Absolutely. Okay, so you have that. Hippocampus, memory part of the brain, goes through the roof, hyperactivated as well. So you have memory part hyperactive, motor part, movement part hyperactive. Okay, the LPFC, the frontal part of the brain shuts down.
What is this in charge of?
A rational decision making.
Oh yeah, the rational decision making. Yeah.
What I'm trying to say by saying these parts shut down, these.
So if you really want to be rational, but
well, what's happening? What I'm trying to say is that what I'm trying to get at here, Faisal, is that we are looking at a dreaming brain.
Yeah.
Okay, activation in the visual part, dreaming guy. Okay, he's motor part of the brain is active. dreaming guy. He's walking by.
But the motor part of the brain, people would think that if we're sleeping, but we're not moving, how is that active?
You got it. These are the kind of questions I love to get from students. Now, you're not a student, you're my colleague, but when
I'm a student.
When I'm lecturing in classes,
science.
I love to get these kinds of questions. Yeah. In this part of the brain, the pons and medulla, you have a system called the inhibitory system, whereby you have glycine and GABA, inhibitory transmitters, chemicals. So the brain has two types of chemicals. You have the excitatory chemicals in the brain that makes the brain hyperactive and, excited. And then you have chemicals that quiet down things. These are the inhibitory ones. In the system, you have inhibitory neurotransmitters, glycine and GABA, going down the spinal cord and activating. You have alpha motor neurons and paralyzing your entire body during REM sleep. So in REM sleep, you are completely paralyzed from head to toe. You cannot move.
But you're moving in your brain.
But you're moving in your visual percepts, in your dreams. You're moving.
Wow.
That's why you are having motor activity, but you're not able to move.
But why in dreams? So that's happening. Your visual cortex is interpreting that as a dream, as a visual that is happening, and everything is there. You're able to move. You're able to feel emotionally, and we do get a lot emotional in dreams.
Yes.
But it feels like a very bad constructed AI video where you're in one place, and then that situation changes, and then you're on top of a house, and then someone's running after you, and then when you try to look at him, he turns into a cat.
It's fleeting. It's elusive.
Yeah.
Well, we'll get into that. So the whole neurochemistry can explain it. Yeah. So first of all, we said you're paralyzed from head to toe. Why is that important? Well, you don't want to act out your dream and hurt your sleeping partner, hurt yourself, right? So if you have a crazy dream with Faisal, doing all these crazy things, he's on the moon, maybe he's having a chat with the Queen Elizabeth, and then he's seeing Messi, and everything is strange, bizarre, places, people, and, time is warped. So if you were to act out those dreams, you'd hurt yourself, hurt the person sleeping next to you. Yeah. In fact, there's actually a condition called RBD, where you have people acting out their dreams and shouting and screaming and doing all kinds of bad things.
We'd like to get into sleepwalking as well.
Yeah, we'll get into that later, I hope. But the point is that you can literally see how that's not very good to have.
Yeah.
Now, this is the first point. Then, now you can move about in the dream, paralyzed and safe. It's almost like a safe space or laboratory free of fatal consequences. You can do whatever you want in this testing lab, and essentially, but there's nothing fatal. You won't hurt yourself. The prefrontal shuts down, specifically the DLPFC shuts down. So that's why the world in the dream is illogical. Time, places, people, a sense of a cohesion and seeing the world in a cohesive, logical way. Baland is sitting here in a chair. He's wearing a tie. He's in the studio with Faisal. Munira's sitting over there. There's a roof. I'm going to the airport later. Cohesion, narrative, structure. All of that is down. Yeah. The LPFC goes down. So it's warped. Okay? That explains that. Now, you might say, well, if the prefrontal cortex is down, how come I feel all kinds of emotions like guilt and, things that have to do with the emotional intelligence stuff? You feel embarrassed in your dream, anxiety, and that. That's because that's in the medial part of the brain. Remember before with the train? That part of the brain does not shut down in dreams. That's why we have all these kinds of emotions that are social in nature, and we have anxiety.
You still feel a lot in dreams.
You have intelligence. You have emotional intelligence in dreams. That's what I'm saying. Mm-hmm. You have that kind of guilt. You may have guilt in dreams and things like that. Self-referential thinking is there. That doesn't shut down the medial part. Now the motor cortex goes up. The emotional part of the brain goes up, and that's why the dreams are so extremely fearful. Dreams can be highly emotional. They can be pleasant too. Dopamine is through the roof in dreams. In fact, there's that mesolimbic dopamine circuit I mentioned before. If you have a stroke there, you will not dream.
You will not be able to dream.
You won't be able to dream. So this shows you that dopamine and bliss is also hugely important for dreams.
Well, but why is that part of why is it? See, when you spoke about deep sleep,
yes,
and what it does to your body and your brain, makes sense. But what does REM stage or What does dreams do to you?
I don't want. I see what you're saying. You feel you're getting bored by me mentioning all the parts of the brain. But look, this is not.
No. I'm just saying. What's the point of dream? What's the point of that stage?
The point. What I'm no. It's a fair point. I would get bored too. But my point is the following.
I'm not saying.
No. My point is the following. I get excited because I'm a neuroscientist and look at the brain. But we know what excites me, Faisal. What I'm trying to get at here. I'm trying to get at the structure of a dream itself is very much influenced by how the brain looks. So the fact that you have parts of the brain that has to do with behind your ears, you have a center called the vestibular center. It's involved in balance and sense of a self. It's hyperactive. That's why you feel like you're in a spaceship and everything is floating. Okay.
Yeah.
The fact that the motor cortex becomes activated. That's why you move in the dream. Emotional part explain why dreams are terrifying. The dopamine part goes up, explains why dreams are highly blissful and rewarding, and there's sexual dreams and intimacy and pleasure.
Yeah.
But that has a neurochemistry to it. That's what I'm trying to get at.
But there are, again, based on that as well.
Yeah.
Why do we dream of things that we're thinking about? Like, some people, I want to maybe dive into a little bit of the final result of all of that coming together. Mm-hmm. And we can speak about some even spiritual angles to it in terms of, and I know you're very, one of the most inspiring stories is Yusuf alayhi salam and him interpreting dreams. And I know that story inspires you a lot. Does, And I want to jump into that really. Let's do that. All of that coming together.
Yes.
And that is fascinating, right?
Yes.
How do we use existing memories? I know people who interpret dreams, and it's you hear a lot of stories where there's almost like a law of attraction, and maybe we can delve into that type of topic. So what happens?
What happens is that when you dream, you are pulling from different circuitry. First of all, your hippocampus, you draw a lot from memory, a lot of stuff from memory you draw, information from memory that helps you, that taints the dream. Is your question, why does a dream have a certain...
Yeah, I mean, we see people that we know.
We see people that we know, yeah.
Sometimes when we worry about something, it comes back in the dream.
Yeah.
Is it a sign or is it something natural?
It's a good question.
Do we dream about things that we've seen today?
Yeah. Scientifically, the short answer is that, so why do we dream? Why do we have certain dreams? Scientifically, we would say we don't know. So one hypothesis by Alan Hobson was that we dream because the brain has all the activity from the PGO waves and the acetylcholine going up to the brain, and you have all these parts of the brain shutting down and becoming active, and your brain is a storyteller, and it goes, how can I make meaning of all this neural activity, of the brain activity? What I'll do now, I'll just create a story based on that. So it's kind of like almost like randomness. It's trying to make sense of randomness. So this is one theory. Is this a very good theory? I think it has a lot of grounds to it. It's interesting, but it's not the whole story. And I think Hobson was getting at more later on as well. Then, what can it be then? It turns out a lot of dreams that we dream about have to do with experience in our own lives, things that we experienced, and the emotional core message of those experiences. So that those are being interpreted in our dreams. Not actual replay. There's not a replay in our dreams, but their emotional core.
Yeah, they're never replays.
Exact replays. Their emotional core. So let's say studies have been done where they have people journaling, and then they will write down their concerns and themes around them, and they will dream about those concerns and those themes as if they're doing their dream is trying to find solutions to their emotional problems. Look, the brain... And
that makes sense to me.
That makes sense. So one idea is that the brain is almost like an Indiana Jones. And it takes you through this exploratory journey where you walk around in an art museum and shows you different visual things. So you see this painting, you see this beautiful sculpture, you see all these things, and it looks at what evokes your emotions and makes you agitated and emotionally aroused. And if it makes you emotionally aroused, the brain says, oh, this is important. This theme of you chatting with this person over here, this person you know from work, obviously has some kind of meaning to it, so let's explore this more. And by doing this, it's kind of massaging and creating new circuits around that so you can cope with those situations more in real life.
Just confronting it
and dealing with the emotions around it. So this is one theory. And also related areas or theory is something called threat simulation, which is that you dream because you want to see yourself in your dream in certain scenarios in a virtual reality testing space free of fatal consequences, seeing yourself jumping over a river and running from a tiger and escaping this attack from this bear over here. And by seeing yourself in your dreams surviving that and jumping over that stone and jumping into that river and swimming here and there, and you train your brain to be able to cope with that in real life without having to actually risk your own life. So it's a way of
training your mind,
building new circuits without actually running the risk.
But not many people remember their dreams. I remember mine.
Yes.
Almost every day. I'll wake up on the 5th. There was a journal next to me, but I'll forget them the next day.
Right.
But I have a good friend of ours here, our colleague. He never remembers his dreams. So is this? And many people listening probably they say, "I do not dream." So do they not dream, or do they not remember their dreams? Most of the time, I'd say.
Yeah. So we dream in about. So you sleep 8 hours, let's say.
Yeah.
Within these 8 hours, you have 25% of that sleep is REM. And you have cycles of stages of sleep. So I just want to make this clear. You have these cycles of 1, 2, 3, 4 deep sleep and REM sleep is about 90-minute cycles. 90, 90, 90. So you have 4 blocks of this. Overall, 25% of this whole architecture is REM sleep dreaming. So all of us had that for a few hours last night, at least an entire REM stage you were dreaming. Yeah, you remember only a few fractions of it, probably. So the question is why? How come we don't remember our dreams? This is one key question. Right?
Do we wake up on a REM stage? Usually, naturally.
No, it's typically not.
Sometimes you wake up, you'll know what you just dreamt. So do you wake up on the last cycle, on the last stage?
Typically you wake up outside REM. So if you wake up, you can wake up from REM as well.
But what's usual? If I didn't have an alarm?
Yeah. Typically, you go out in the more lighter stages.
Okay.
These are lighter stages.
Okay.
Whereas this deep sleep, if I wake you up from deep sleep, right, you'll be groggy and you'll be tired and if I wake up from REM, you'll have a dream to tell me, most likely. Or I dreamt about this and that. Now, the key point here is, how come we don't remember our dreams? And it has to do with the fact that when you are in REM sleep, 2 key neurochemicals shut down.
Which are?
Serotonin and noradrenaline. In fact, in the whole 24-hour cycle, the only portion of your consciousness state where you don't have any noradrenaline and serotonin is in REM sleep. Okay, noradrenaline is secreted by a part of the brain called the lucus ceruleus, about 32,000 pitch black cells. Okay, for the nerds who wants to know, all right, it's deep inside the brain, and serotonin is produced in the raphe nucleus, dorsal raphe nucleus. These 2 parts of the brain shut completely down during REM sleep. And so when you have that and you lack these neurochemicals, you cannot store new memories. Your hippocampus, which is overactive and giving you all these kind of memories from your world and your life, cannot store new memories. It's not, instead of being input fixated and taking all the input from the dream and storing it, it's output fixated. It takes information in the world and it creates stories around it based on all the acetylcholine now flooding your brain. So acetylcholine goes up and...
So you're not supposed to remember the dreams, but so you do.
Yes.
So how do you remember some of them?
Well, some of the dreams you remember because in the last portion of when you wake up, if I wake you up initially, what you have is you have a few seconds of serotonin and noradrenaline flooding your brain. So you have a few seconds of a window of opening where you can write down your dreams. Oh,
so it's like spilling over.
It's a spilling over, but it's also a part of, if you want to be totally technical, the wakefulness process is actually a process where noradrenaline and serotonin wakes you up. It floods your brain. It's like it goes from being shut down to now flooding.
So that's
you need it to be awake, right? It's the parts of the brain that's needed for being awake. But on the noradrenaline part, I think what's something really interesting is that noradrenaline is the chemical we have in our brain when we are stressed and anxious.
Noradrenaline.
Yes. And so when you don't have that in dreams, what it allows you is that it allows you to experience things in the world in a non-frightening and terrifying way. Embracing them. So you see yourself, chased by a lion and a tiger, and you do have adrenaline in the body, and you have heart just beating and pulse and all that is going up. But there's no noradrenaline in the brain, so you kind of learn how to deal with a fearful and terrifying experience in a non-threatening way.
So you're in a practicing ring where you experience it for full, but nothing's going to happen.
Can you see how good that is?
That's amazing.
It's amazing, yeah.
I like this theory more.
I like this.
I like this theory where you're put in a place to deal with your emotions, and then it's like a practicing arena.
It's a practicing arena, and it makes a lot of sense. There were studies done with people who went through a divorce, and then they looked at how much they dreamt about their ex-husband, and the less they dreamt about their ex-husband, the more they were likely to develop depression a year later.
Oh wow!
So to be able to dream about their ex-husband and in REM sleep and having no adrenaline and stress hormones and chemicals in noradrenaline in the brain, they were able to sort of just make the whole thing much more softer and less traumatic on their brains. So I think this theory makes a lot of sense.
Interesting. So what about the first stage, second stage, third stage, and those cycles keep going for about 8-9 hours until you wake up. So that's sleep. That's principally what happens. Yani.
Yes.
So now we're going to talk about the situations which aren't normal, right? Yes. So one of the situations or people speak about a lot, is lucid dreaming. And it happens to me every now and again where I realize that I'm in a dream. Yeah. And then I start enjoying myself and I start exploring. Yeah. So what happens here? Is there like an error, a glitch?
It's a great question. So lucid dreaming happens so we mentioned that the DLPFC shuts down when you go into REM sleep. And so your sense of awareness, not only the logical and cohesive sense of the dream is off and you feel the world is surreal, but it also is the part of the brain that has to do with self-agency and awareness. Yeah. So if that part shows that when it shuts down, that's when I do not know that I'm dreaming when I'm dreaming. That's because of the DLPFC shutting down. Yeah. So you can imagine if I was to have the DLPFC activity and part of the brain become active, dance with activity suddenly during REM, what would happen now?
You'll know that
I would know that I'm dreaming when I'm dreaming. That's exactly what happens. The more...
And throws the second theory that we both like, of you being and practicing and understanding.
Absolutely. And so the more active it becomes, the more lucid you become in your dream, the more aware you become.
Some people train for that. Is that
you can train it. Yeah, you can train the DLPFC to turn on more on manual instruction.
I remember it happened to me a couple of times. Yeah. And I remember those dreams, and they were dreams where once I realized, I was very young, I realized I'm in an amusement park. Mm-hmm. And one of my family members was telling me, come on, Faisal, let's end the dream. And then I realized that I'm in a dream. Yeah. And then I remember for that dream, I was just enjoying myself, going on every ride in that amusement park, which was
fascinating. Yeah.
Fascinating, right?
Fascinating. It's fascinating. A lot of these lucid dreams will come from like you meeting somebody you're not supposed to meet, like going around and then meeting like a prophet or meeting like Shakespeare. You go, oh my God, I'm not supposed to meet this person here. What's going on? And then you go, oh my God, this must be a lucid dream because otherwise I wouldn't meet this person.
A lot of people wake up and they say, I've met that person.
That triggers it. It seems to trigger it a lot. These kinds of experiences. But yeah, the more activity in the DLPFC, the more you become lucid.
But are dreams possibly, can they be interpreted in a way where it's scientific, where they're like alarm bells to something that is happening in your body or something that you're going through without you knowing?
For
example, someone who has high blood pressure, he's going to have a specific type of dream.
Oh, this is a great question. Yes. So I'd say this. Yes, your dream is not only influenced by your brain state, but also your bodily state. So if you're dreaming about, certain, like if you have high blood pressure, it will affect how you dream, for sure. That's undoubtedly the case.
When I have heartburn, definitely.
Yeah, it influences dreams. So anything that can influence you physically, and even like the temperature of the room, if you have like smoke from the room coming in from a nearby house, this will affect your dream. You might see yourself in a burning house. Or if you have the AC is too cold, you might find yourself on Greenland in your dream. So definitely anything that influences your...
It's going to be the United States, so...
Exactly. Exactly. It's called the U.S. Another state, huh? Absolutely.
Yeah, but I mean, what's happening in your environment and where you're sleeping can affect what's happening in
the dream itself. Absolutely.
Interesting. So what do you think about interpreting dreams in general? Because of, again, going back to Yusuf alayhi salam.
Yeah.
And that in specific, do you think that there's a side that hasn't been explored properly? Do you think that there are some results? Tell me about this.
Interpretation of dream it's a great question. So there is dreams from a scientific perspective where you interpret what these things mean and you link it back to the emotional state and the life you had and experiences and all that. For sure, you can do that. But then are there other layers to dreams? And this is where I talk about, like, I often make this distinction between psychological, neurological, like brain explanations for things, and then possible spiritual explanations for things. And I don't think these two clash, these two worlds. I think they can exist. Obviously, when I do science, I don't talk about spirituality and religious interpretations of dreams. These are two separate worlds. But from a more spiritual angle, obviously you can definitely interpret dreams from a... Is that what we're going a little bit? Let's so do that. I think from a spiritual angle, messages from... For a long time, by the way, we thought dreams were only messages from the divine. I think now it's clear that the brain plays a huge part, the psychological aspects and all that. But it doesn't negate the fact that, God could send you messages through your dreams. There's nothing in science that would negate that could happen as well.
Yeah.
So, and even in Islam, right? So you have dreams that are from the self, and then you have dreams could be from God, like a message.
Ru'ya.
A ru'ya, right?
Yeah.
Ru'ya salihah.
Yeah.
A bushra. And so there's nothing wrong with that, having that worldview. And in fact, and interpreting that is now we're getting into some spiritual stuff, and you have to maybe have knowledge of the religion in order to say, what does certain dreams mean? Like if I see my right? I see something like this, stars and the moon prostrating to me. What does that mean? That is going into now spirituality and religion and all that. So it kind of goes outside my domain, so to speak.
Yeah.
But what I'm trying to say from inside my domain is that there's nothing that would negate a spiritual world and a spiritual explanation as long as it's kept away from the scientific world, because these two worlds are not ready to meet yet.
They should not.
Not yet.
They're not yet.
Yes.
Amazing. What about we're going to speak about the athom, which is sleep paralysis.
Yes.
Think something what happened to you and changed your world as well.
Absolutely.
But jerking before sometimes, and that happens to, I've looked it up and it happens to men a lot. I thought there was something wrong with me when I jerked once, and I realized I just woke up through a jerk, and then I realized that happens to most men from what I read. But maybe sleepwalking, jerking is just when you make a move. Sometimes when you feel like you're falling, you'll just you'll jerk, right?
Yeah.
So what happens here? You're supposed to be paralyzed. How did you break through?
That's a good question. So in the initial stages of sleep, remember, you're not paralyzed, right? So stages 1, 2, 3, as you fall asleep, there's no paralysis. This is the first point. Second point is that when the brain shuts down, it's not perfect in its shutting down. It's almost like when you try to shut down your computer, sometimes some tabs stay open and then maybe there's a crash here and it's not completely coordinated perfectly. Same when you fall asleep. Sometimes the motor cortex may temporarily stay active even though you are, shutting down other parts of the brain, and that's why you have the hypnagogic jerks.
Yeah.
That's part of parts of that, this coordination in motor activity and other parts being lower in activity. Other people would say that we used to sleep in trees and then high places, and then in order to prevent falling, it would be good to have this mechanism of these jerky movements, like having these hypnagogic jerks.
Okay. What about sleepwalking?
Sleepwalking.
There's this girl that has a TikTok account. I need to show you this, man. She has a and she walks and she talks, but she walks around and she talks to people.
Yeah, crazy.
There she is. And she's asleep.
Yeah.
So is that normal?
Well, it's not that normal. It hits about 22% of the population have had it before. It's about 14% in children. It's definitely not normal, but it's relatively normal.
Relatively. Yeah. So that's not unheard of. So
no. Basically, her experience is pretty normal. That you have your eyes are wide open. You start waking up, walking around. Some people might go to the kitchen and start chopping up food and eat raw food. It's a variant, a type of sleep.
How are they able to tell what's happening and at the same time not be there? And
it's kind of their brain goes on autopilot. It somewhere it knows that, you know, in the memory system that these things are supposed to be here. It's like a definitely unconscious agent. That's where agency is out of the picture. It's like a zombie, but it knows where things are, kind of relatively speaking. It's not that aware, but it can definitely. You have cases of people going to the car, starting the car and driving.
Oh, wow.
Yeah, driving on the freeway and they're sleeping. Their eyes are wide open, but they're fully asleep. And this happens because as they're dreaming, the cortical part of the brain is slightly activated. So remember we talked about how the brain shuts down overall when you go into sleep, the prefrontal mainly. If there's a lot of limbic emotional activity, it can tickle the outer prefrontal such that you become awake and you can walk about, but only to a certain extent. You're not fully awake. But here, importantly, the motor regions of the brain are highly active, as well as the lower part of the brain that has to do with balance is highly active, so you don't fall. And so you're walking around with a half activated prefrontal cortex, and you have all these bizarre things, and you're doing all these things. You're driving cars and potentially becoming. There's a case that I sometimes highlight. I think is important. There's this guy came. His name was Kenneth Parks in Canada.
Okay.
He had some gambling and financial issues, so he was about to go and see his mother and father-in-law to chat about his situation, and so that was supposed to happen the next day. So he was sleeping on the couch, you know, as the TV was buzzing in the background. Okay. He woke up and suddenly, you know, in the middle of the night, while his eyes were open, he was, you know, fully asleep. Woke up, went to the door, opened his door, started his car and drove, I think about 14 miles, all the way to his parents-in-law's house. There he broke in, okay? He got in, broke in, went to the kitchen, took a big kitchen knife, went straight upstairs, all right? Killed the mother-in-law, right? Tried to kill the father-in-law, but was unable to. He fought back, right? Yeah, I think he may have hurt him as well. Butchering. I mean, his mother-in-law was butchered pretty much. Went down, took the car, and started driving again. At some point as he was driving, he looks at his tendons, and he his blood coming down. He wakes up and he says, "My God, what happened?" He says, "I think I may, I've done something wrong." And he goes straight to the police station, and he goes in there and says, "Look, I think I've killed somebody because I have this knife. I have blood here. What's going on?" And obviously they took him in, and eventually his case was examined, and they found out that when they were, obviously initially they thought he might have actually killed them without being sleepwalking. That sounds like
obviously, yeah. That's what anyone would think.
Anyone would think that.
He regretted it, and he just said,
yeah. But as they sort of had this analysis of his brain, and he measured the activity of his brain, they found that he was in deep sleep. He would go in and out of deep sleep about 10 times each night. So his sleep architecture was completely fractured, and he would not stay in deep sleep. And this clenched the case, and he was found non guilty. In fact, of
he's the guy, huh?
Is it Kenneth Parks?
Yeah.
Oh wow, crazy case. I am highlighting this not to make it sensationalist, but really this is a huge case of showing that sometimes our brain can make us do certain things. And does this guy have free will? I don't think he has free will, and did that.
No, I don't think
free will.
No, I don't think he's what do you call it, muhasab.
No, he doesn't have no. And this is in order to have free will, you really need. And this guy didn't have it here, but you really need to have what I call the Pepsi Cola test again. If you can ask somebody in sleepwalking, make him choose between Pepsi and Cola, can he make a choice? No, he can't. Somebody sleepwalking, said Pepsi Cola, he cannot make a choice.
No, his brain, he's unconscious.
He's unconscious. So this is one of the criteria of
yeah, he's unconscious. He's not responsible for his actions.
No,
he's not.
But yet he did something terrible, right?
Exactly.
So,
wow.
So this is sleepwalking and what it can lead to. But often it's not that fatal. I have my brother when he was about 15, 20 years ago, we were in Iraq. Or he was in Iraq. I was back in Copenhagen. He was a kid. He was about maybe 10 years old. In Iraq in the summer, they used to sleep on the roof
Yeah.
Because it was there was no ACs or anything like that.
We used to do that in Kuwait.
Yeah, I used to, when I visited too. It's pretty cute. So we all sleep on the roof. But then it's dangerous because the roof over there back then was very, very flat.
Yeah.
So if you just kind of go to like the border, you can fall down the edge. It doesn't have the fences. Back then it didn't. We just like, especially my mom's house, it was very poor. So it was just like flat thing. So my brother woke up in the middle of the night, sleepwalking, started to play soccer.
Oh, no way.
Play soccer up there, and he almost fell down. They woke him up so he didn't fall down the building. But it can show you sometimes it can be.
Yes, it happens more with kids, right?
Yes, and that has to do with maturation of the circuitry. The prefrontal cortex, as we get older, it matures more. As we get older, it matures more, and it can inhibit any kind of activity from the emotional core of the brain. That's why people that in the teenage years are more impulsive, they can do more impulsive stuff. I
remember that I had one dream, and then I woke up by punching. I was very young. In the dream, my brother was, I don't know, I was playing, and he just made me so angry and so mad.
Yeah.
I woke up and I punched the pillow next to me.
Yeah.
And I was very scared that I was able to do that. I was very young. That never happened before. I think I was 12. I remember that very well, that I acted on a dream by being very angry, and it's like I just woke up by just punching the pillow next to it.
It's amazing. For me, actually, what the dream world is, I want to say that. I want to say this. I mean, the dream world is it's crazy. There's so much there, and But from personal experience, I do feel I've had tons of these like ru'ya, where I've seen something in my dreams, and it did happen.
Yeah, same.
And I get this all the time from students telling me, "Can this happen?" And I have to say, from scientific, from a science world point of view, there's nothing to suggest that. Nothing in science will allow that yet. But personally, you have it all the time of experiences like that, and I think, it's something that's something special about it too. Like having a true dream, it makes you feel closer to God somehow.
100%,
right?
Yeah, 100%. And look, and that's where I reason stuff is. This world is crazy in a sense where there's a lot of things happening and there's a lot of science behind it. And if that to you is not enough, if you just look at existence itself, that is more than enough to justify that there is something. Like me and you wouldn't be able to just exist.
Yes.
This whole thing, this whole conversation, that me speaking to you, me being someone, me being a soul, me having conscious.
Oh yeah.
This whole thing is by itself mind-blowing. For us to say that there is something that has created all of this is less mind-blowing. And it's, for me, is more rational.
Yes.
Than just understanding that there is something like this happening and existing. You know what I mean?
This is what happened to me when I was a teenager. To loop back to the very beginning of this conversation, when I was a teenager, that hit me. I went, my God, I'm this person. I'm stuck in this flesh and bone called my body. I am a person. I have a certain voice. Why am I here? Why me? Why now? Why here? What is all this about? Is there a God? Why do we walk around, these upright beings, people talking to me? Like, I'm going really deep into the rabbit hole here.
Yeah.
But really, like, questioning all this, and this is where I find God. I was isolating myself for a couple of months and just meditating and just thinking and engaging in prayer. And I thought, my God, there's something to all this, and there must be a God. And it just, my belief in God, I want to make this completely crystal clear. My belief and my faith in God took me from almost prison, almost criminal, like almost gangs, to where I am today. I'm not saying I've accomplished anything, but it's all by God's grace. And if I didn't have had my faith and belief in God, I wouldn't be where I am today at all. It was all God's blessings. It gave me discipline. It gave me faith. It gave me hope, optimism. And it just took me where I am today. It's all that faith and knowing that it didn't come from me. Had I done something, I could easily have ended up in jail or dead by like other people. But I didn't. And so I know this, and I will never take it for granted. And, inshallah, as they say, hopefully.
Yeah.
And man, this is how I feel about it.
I'll tell you a story. And feeding off of what you just said. I was in the UK studied pharmacy. I stayed there for an extra year and a half, and I just didn't want to do pharmacy, and I really wanted to do media.
Yeah.
And I was praying, and I had almost like an intellectual battle with my parents and my family, and they all looked at me. They were almost ashamed that I'm leaving pharmacy to do media now. Although we do come from a media family, or works in media, but I was very unsure. I had all of these emotions and all these feelings, and then I went to a khutbah.
Yeah.
And those are the things where we might speak about just some other stuff related. But I walked into that khutbah, and then the imam said those exact words, and he said, "Why are all parents forcing their children to work in medicine and engineering? Why don't they let them, for example, work in media?" He said this. The things that I felt that moment just made me so relaxed, and was like I was carrying this whole weight, and I just suddenly dropped it. Yeah. And those little this moment specifically made me make a decision that I know that I just want to do media. And I worked in pharmacy for 5 years to be able to get an exit to go into media. And I knew from that moment, that was before I started working in pharmacy. Yeah. But that moment kept me going for 5 years to be able to get my license, to be able to exit pharmacy.
That's incredible.
So that to me is the meaning of life. Those little moments to me as a person, and the existing questions that you asked yourself, those little moments define me as a person, defines my objective in this world, right?
Yeah.
And that's when this whole podcast makes sense, bridging intellectual, hopefully that's what they're doing, intellectual conversations, trying to make sense, trying to bring good, and trying to be an added value to this world. And that's really where this whole thing ties up with me personally. And yeah, maybe the last thing that we want to talk about here is, a lot of people say the brain and imaginating and the law of attraction. What is your take in terms of imagining stuff and then putting your brain in a position or in a state where you're able to find your way into things that you think that you want to end up doing?
It's a great question. So, a law of attraction, imagining things. So I want to get to that. Before I do, I want to weave in a little anecdote, because it kind of goes to what you're saying. Okay. It kind of made me remember what you said. So back when I was in the ghetto and I was getting poor grades and almost thrown out of school, I had 25% absence in high school, the worst kid in university and in high school. And I remember in that year after high school, I was in my father's pizza shop working, like just another young second generation kind of immigrant refugee type kid. And I remember a lot of things would happen in the pizza shop, by the way. I was working there. I never thought I would go to university or anything like that, but I was just in there working, and this is what the time I was kind of reading the books and all that. I remember one time a guy came in with a bunch of papers, and he said, it was very nice to me. "Oh, how are you doing? You're very nice. You're doing all. You're very good kid. You're very good manner and all that." Yeah, so that's good. But then he said, "What are these papers?" I said, I was curious. "Oh, those are not for you. Those are my grandson." This guy said, he's going to Oxford soon. And you shouldn't. And I felt a bit hurt, actually. I said, what is that? I felt a bit hurt back then. But around that same time, I was working in the pizza shop. One day, my father said, "Look, son, I had a dream of you. It was amazing," he said. "I saw you at this place, like a university setting or some kind of theater setting, and you were giving a lecture or something, and all these people were listening to you." I said, "Me giving a lecture? I'm not in my life giving a presentation. What do you mean?" I'm like, I'm 18 years of age. He said, "Yes, all these people were bowing their heads for you, like almost like, being grateful for what you're doing, and you were talking, and I was there, and I was so happy." I said, "Wow, that must mean something." I took it to heart, really took it to heart. But I couldn't imagine myself one day giving a lecture or anything like that. That sounded so far-fetched. And that actually was part of my whole deal of going to Egypt, after he told me about his dream, that one day maybe I'll have maybe قَدْ جَعَلَ رَبِّي حَقًّا, maybe something will happen where I speak on a stage and people will say, "Oh, this was good," or something. So this kind of, there's something going on.
It is, but you mentioned إني رأيت 11 كوكبا والشمس والقمر رأيتهم لي ساجدين.
Yeah.
Then the ayah after that قال يا بني لا تقص رؤياك على إخوتك فيكيدوا لك كيدا إن الشيطان للإنسان عدو مبين.
Yes.
So the things that you see, I really believe that you shouldn't tell. It's very intimate and it's very personal.
Yes,
and so it's what you see.
Yes.
See, that happened a long time ago. At the time, I didn't tell anyone.
Yes.
And it kind of helped me build that energy within me. Now that it has happened, I think that's the first time I speak about it, by the way. So I just felt like but in terms of what you see and the things that you see in your dreams and the things that you feel, I feel that we should be very careful in terms of who we should share it with.
We should be. And the reason I'm sharing it 100%.
Now that it has happened, it
happened, yes.
Yeah.
It manifested,
right?
Absolutely, it has. And it shows you that sometimes you can be in the weirdest places in your life.
Yeah.
Okay, you are literally like, imagine somebody who's like, people will tell him, I used to go like in the ghetto, some of these people that mentor kids. I told them I'm in high school, I'm about to graduate, and they looked at me, and this guy's supposed to be a mentor, is like, a 30, 40-year-old man, and I'm like this 16-year-old kid. He said, you in high school graduating? He laughed at me. You were the most criminally mischievous kid. I wasn't even criminal, but I was just mischievous. I was joking and just, very mischievous. You understand?
Yeah.
And they couldn't believe me going to high school.
Yeah, you wouldn't have imagined yourself 1% that it'd be that guy.
25% absent rate. I never had more than a D or E or F in my entire high school. It was just horrible. Only the last 6 months of my high school, I got a few okay grades so I could graduate. I don't understand how it happened, but somehow God changed the trajectory of my life through dreams, inspiration, and ultimately belief in Him. When I started to have belief in God, my entire life up to that point, I didn't have iman in the real sense. I wasn't like a good person in the, I had faith, but I wasn't practicing. I didn't have any sort of structure to my life. But once I got that's when it all changed. Once I became more spiritual and I developed spiritual discipline and became better mannered, became a better son, became a better friend, became a better neighbor. That's when everything changed. So that's what I'm trying to get at.
Amazing.
Yeah.
I love that.
Yeah.
When you become a better person, the world becomes better for you. And that's 100% true. And I believe in that 100%.
Yeah. You become more empathetic. You become more considerate of others. I used to have I had empathy because my parents were empathetic, but I just became more empathetic with time and spiritual depth and personality growth. So those what I would say.
You spoke about structure. So if we were to end the episode then about structure and in terms of waking up for Fajr, because you mentioned sleep, something happens in the first part of the night.
Yes.
So waking up for Fajr, is that generally good? Scientifically again, waking up, or do we need to structure? And what are the things that we should think about for brain health? Are there specific supplements? Or is there specific food or stuff that makes us better? And one thing that is mostly underrated that's damaging us. So just general maintenance now. How would you think?
Maintenance. Yeah. So I'd say waking up for Fajr and praying and all that, engaging in spiritual activities at night, it's a very good and healthy thing. So any scientist or anyone will tell you that having spirituality is a healthy thing. Even an atheist will tell you, atheist scientists will tell you, being a spiritual person buffers you against stress and life's adversities. That's a good thing. And in the night, you are hyper, waking up, being hyper spiritual in the night, everything is dark, everybody's sleeping. It's a very healthy thing. Now, obviously, you don't want to sleep at 2 a.m. and wake up at 4.
Yeah, you want to sleep early.
You want to sleep after like sunset or like a relatively early time, not too late.
Does it make a difference on the body? Let's say you're not going to wake up for Fajr.
Yes.
And someone sleeps at 7 or let's say 9 and someone sleeps at 1 in the morning.
Yeah, so I do want to add here there's a genetic difference in terms of when you want to fall asleep. So people being somebody who sleeps later is genetically predisposed to some extent. So about a third of people want to sleep like early, like maybe 8, and then half will want to sleep a little bit later, and then they're night owls. There's also genetically predisposed. But generally, you want to sleep as soon as you feel like sleeping. You don't want to extend that window by using screens and being active. You want to just kind of rest. Now, generally then you wake up whenever in the middle of the night or in the
Do you think we should have alarms, or there's a new thing now called Sleep Cycle. There's an app where it try to gauge which stage you're at.
And wake you up maybe after, yeah.
Oh, so it wouldn't wake you up during deep sleep. It'll wake you up during
maybe early stages.
Early stages. Yeah.
It's you can do these, but I wouldn't personally go too much into it. No, I would just I'll put an old-fashioned alarm. Just put an alarm. Just make sure I get enough sleep, and then make sure that it's not too loud, maybe, so it doesn't spark my blood pressure too much, and just like a low alarm that wakes me up, and then I would do that. But there's nothing wrong with waking up very early and engaging in prayer and spiritual worship. It's a very healthy thing. Just make sure you get enough rest before it. So I'd say that. And then general maintenance then.
Yeah, supplements. There's one magnesium. Is it glycinate, is it? Or there's a specific type of magnesium?
Bisglycinate, yeah.
Is it glycinate?
Yeah, bisglycinate. I think that could be good. Magnesium is pretty good for heart and circulation and rest and lowering anxiety to some extent. I think definitely good.
There's one that crosses the blood-brain barrier. Was it glycinate or was it another one? I haven't
looked at that. I'm not aware.
I'll send it to you.
But bisglycinate is pretty good. The bisglycinate one. Fish oil is really good for BDNF and GDNF and plasticity.
Yeah, I heard about fish oil being very good for that as well.
Absolutely. Fish oil, I would take that. Vitamin D, maybe not so much in Kuwait, but other places.
No, you do need in Kuwait because you'd think we're exposed. Yeah, everyone is deficient.
Oh, really?
Munira and I, we've done blood tests, and we're deficient, both of us. So we had to take a course. Yeah.
Yeah, exactly. When I used to live in Egypt, I also was deficient when I was there. Can you believe it?
Yeah, I'd believe it. It's because it's not nice to go out in the sun.
It's
too hot.
It's too hot. So vitamin D, I would take that in supplements realm. Make sure, and fish oil, vitamin D, maybe multivitamins just to make sure you get everything covered. Magnesium is good. I would exercise every single day or at least 3-4 times a week. Cardiovascular, some couple of weeks of strength exercise and resistance training. At least I would do that.
Yeah.
I would make sure I have a lot of social relationships, strong relationships, social, where I'm ideally with like family, friends. The more physical touch is better. You release oxytocin when you get in your physical touch. So when you hug your mom, for example, you have oxytocin. Oxytocin directly reduce the activity of the amygdala and also cortisol and things like that. So lowering your overall chronic cortisol. Meaningful relationships, spirituality, having healthy spirituality.
Reading, good for focus?
Reading is good for focus, but also long-form podcast, nothing wrong with that. It's also good.
Just something that grabs your attention for a long period of time. Huh?
I would do that. And then look, above all of this, I would say the following. I can give you all these advice and say, do this, do that, and this will lead to happiness and health. Personally, I would never leave a conversation without saying, you have to look at the miraculous nature of the world and life itself on top of that. That gives you much more meaning. So by knowing that the fact that had your great-great-great-grandmother cuffed when she was intimate with your great-great-great-grandfather, you wouldn't be here. Somebody else would be here. There was a competition between millions, 100 billions of cells competing for you to, In fact, anybody in that chain of people would have cuffed, you wouldn't have been here. The fact that you are here is a miracle beyond miracle. It's like 300 billion to 1 or something. It's the staggering odds of being born and being here now in this moment is such a miracle that we should not take it for granted. And my point is, once you realize and have gratitude towards that, the fact that you are here right now and you've been given the opportunity to be alive and do good in this world, can give you meaning and health in much more than any supplement. That's what I'm trying to get at.
Amazing. I love that. No, honestly, that is more than enough for us to be inspired, to look forward to tomorrow.
Absolutely.
And the next moment. Thank you so much.
Thank you
for your time, Baland. Shout out to Khalid Lugayan for recommending this episode.
Oh, yeah.
Thank you, Munira, for your time and helping me prepare. Thank you.
Thank you so much. And shout out to Khalid as well. He's been very generous on this journey.
Thank you so much.
Thank you.
Thank you.
Thank you.